Okay, so after the B2, we are looking at a Solid Audio F2500D. And this is a pretty old amplifier. Yeah, pretty old school. It's an old circuit design as well. It uses a P channel and an N channel MOSFET on the output section instead of just one of those. So yeah, we've got 640Ns and 9640s on the output section of this amplifier, and we have the standard 640N, sorry, 064N on the power supply, and these are the bigger case transistors. Now this amplifier, she's staying. Whoo! Absolutely stings. So we've got a very burnt power supply section in here. If I pull over to my other screen, you guys can see. So yeah, we've got a very burnt power supply section here, lots of blackening of the board all by the power supply. Now this is very common when the power supply fails, because when these FETs fail, they create a direct short across your two power terminals. So your battery will just cook the FETs until the fuse blows, or until they blow open, or until a fire starts, which is always good fun. I'm just going to pop my chat out. So you guys can see my chat, because that's always fun when you can see my chat. I have to restart this every time the stream restarts, which is a bit of a headache. There we go. Oh no, it still doesn't like it. Chat, and I just need to go back to there. Huh. Why? So okay. Come on, OBS. Come on, OBS. Show my chat window. There we go. That's better. Okay, we're back in business with that. So yeah, Solid Audio F2500D. So obviously visual signs of damage we've got on this amplifier are quite clear. Dead power supply section. And how do you know the power supply is dead? Well, first of all, she stank. Woo! A bong. And also we can tell that we have a dead power supply because we have a direct short across our power input terminals. So we have a direct short across here. What would happen if you tried to put this in your car? You would blow your fuses, or blow your battery would not be happy. So that's obviously an issue with the power supply section. So why did this die? We need to look at why this amplifier failed and what caused the power supply to go down. Sometimes they just go down of their own accord, but often it's because the output section is dead as well. So we go along each of the output FETs and we check for shorts. So this bank is fine. Let's check this bank. This bank is fine. This bank is fine. This bank is not fine. No good. So we have a short between the gate and the source of this 9640. Well, we've got a short across all three pins. And we've also got a bit of a blackening of the legs here as well. So that one's dead shorted. So yeah, all of the... We've got a bank of 9640s that are dead. So we've got 1, 2, 3, 4, 5, 6. Okay, so we've got a bank here. So it's just these lot that died. And this will have pulled down the power supply. Now, what I'm going to do, this is pretty interesting. I'm going to zoom in on my zoom in camera here, so you guys can see what's going on with the driver board, because this is probably the reason that this amplifier died. If I can get that up in here, get that zoomed in nicely for you guys. I'm literally using the cheapest capture card in the world for this, so it is all over the place. So this is said driver board for said Solid Audio 2500D. So if we have a look at what's going on here, we can see that this has been repaired before. This side of drivers, come on, get in the view, get in the view, get in the view. I don't know how well you can make that out with the resolution, but there is some jumper wire which has been put between this tiny driver here. Let me get that out of the light, out of the shadow, so you can see. Tiny driver here, there's a small jumper wire that goes between this leg and this leg here. because these driver boards have a tendency to fail the vias. The vias, they fail, and so the board doesn't make a proper connection between pads, and so there's been a small jumper wire put in here between this leg and this leg. Now, I would put my money on the fact that this jumper wire, the connection is very poor, because it looks pretty poor. It doesn't look like it's making a very good connection at all. And so because this connection is poor on this wire here, this side of drive may have stopped functioning. And when this side of drive stopped functioning, this other side, so we've got the two sides here, this side of drive stopped functioning, which powers this lot. If this drive stopped, then this side of outputs wouldn't have been switching, okay? And to compensate for this side of outputs not switching, this side of outputs will have been driven very hard by the drive circuit. It would have basically driven this fully, and it would have been trying to power the side that wasn't being driven. And this is a problem, because then this side all heats up because it's basically driving a short circuit where the other side isn't switching, and it usually fails. So although the fault is probably on this side, the repair that we need to make is to this side and this side. Mad headaches. And power supply section we also need to repair. So this is a very involved one for us to look at, which is good because I like the involved ones. Makes for good content. So just whilst I wait for the stream to fill out with viewers, we are going to start removing these screws and get this thing out of the case. And as I do this, the stank becomes real. The stank becomes real. YouTube is still telling me that I have bad video settings. YouTube is still telling me that I have bad video settings and buffering. I haven't changed anything from my last stream. The stream does look alright for you guys, yeah? Output. Use custom buffer size. Keyframe intervals. Ah. Second, 0 equals auto. Okay, so it should be... yeah, interesting, okay. I don't know. Seems to be alright my end. But YouTube does not like my stream settings. It's saying bad video settings for the duration of this stream. Bad video settings, bad. Please use a keyframe frequency of 4 seconds or less. Currently keyframes are not being sent often enough. Alright, let's try changing this manually. Let's try changing this because I don't like it that YouTube says that it's not happy. I'm like, come on, I want to make YouTube happy, you know. Let's try 3. Keyframe of 3. Okay, so I'm doing a keyframe every 3 seconds, so let me know if that changes how it looks at all, or if it makes it worse. This is, yeah, it's a pretty big board. So this amplifier, it's called the Solid Audio F2500D. So you would think it would do 2,500 watts at 1 ohm. In fact, it actually puts out less than that. The 2,500 watts was actually at quite a high percent THD, but these boards are quite good at driving a 0.5 ohm load, and so I imagine that you know, the whole idea with this was that people were going to use it at 0.5 and they were going to get about 2,500 watts out of it at 0.5. So yeah, this board will definitely kick out 2,500 watts, but you might need to put 0.5 ohm it to actually get it to do it, or give it 18 volts or something. I'm not even sure if this one is 18 volt stable. I'm not even sure. So yeah, cheers for tuning in, guys. I hope you look all good up in the live chat. If you've got any questions for me about amps and shit or general audio, give me a shout, man, while I'm undoing this thing, while I'm unscrewing this beast of a 2K, this old school bad boy. People love these amps. People really have a good connection with these Solid amplifiers. John Schofield in the UK is one of the guys who loves off these amplifiers. He loves this Solid. Chris in the chat, what brand is that? It is Solid Audio. I don't think they are in business anymore. This is a Solid Audio F2500D. And this looks like it's been repaired quite a number of times. We've got a mismatch of screws and all sorts going on in here. It's always fun to see. Yeah, cheers, Matt. I am not bad. I am not bad. I'm a bit hot this workshop. I've just replaced my heaters in the workshop. And I've replaced them with ones that don't have a thermometer on them, so I have no idea how hot it is in here. And they don't really have a great thermostat either, so I'm just kind of turning them up and then turning them down slowly until it gets passable in here, but it's still a bit too hot. Still a bit too hot, but that's fine. We can pretend it's summer. Nathan Fenton, when are you going to start doing more videos of your car and subwoofers? Very soon, as soon as the weather gets better. I'm not all about doing a video outside when it is grey and drizzling and pissing with rain, because I'll get my new door builds soaking wet. So yeah, there is a video of the car coming very shortly, I promise, because we are close to finishing the SQ front end, which will make a fantastic video. And once the front end's done, then I can start. This screw just is made of cheese. I can actually start doing subwoofer videos in my car and testing out all different types of subs and sizes and box designs, because that makes for really fun content. So that will be very soon. As soon as the front end in the car is sorted, then I can do the wiring properly, and then we'll get some nice subwoofer videos in my car. It'll probably be springtime, probably mid to late spring, that I start doing experiments with different subwoofer enclosures. I want to mess around with a single 10-inch woofer in an ABC box, which is basically a ported box that has another ported box inside it to allow it to tune to 2 different frequencies. And we're going to use a single 10-inch woofer, and we're going to enter it into proper droppers BB1 category and see whether we can get a nice average using an ABC box. What are those blue square stuff in between the transformers? These are capacitors, my friend. These are non-polarized capacitors. I remember when it used to be your studio always freezing, says Matt. You remember when it used to be my studio? Holy crap, you've been watching for a long time, my friend. Nice. Nice. Color temp looks too cool. Which camera is that on? Is that on this one? Sort that out as well for a start. Oh man, these things just love moving by themselves, don't they? They just love. There we go. That's fine. Oh, for the lights, yeah, the lights. You see, behind me, I've got the lighting in here. Behind me, I have got some LED floodlights, and they did used to not be LED floodlights. They used to be some of the proper halogen ones, but they died within like 2 hours of usage. So I got bored of paying out for replacement bulbs, so I just got some LED ones instead. And yeah, they're a bit too cool, I agree. They are a bit too cool. Too cool. Okay, let's pull this board out. That was much easier to get out than that B2. Let's put that down to the side. What's wrong with the amp? Says Xenos. Scroll back through the video and you shall find out. Everything is wrong with this amp. Everything is wrong with this amp. Power supply section, output section, drive circuit. Everything is wrong with this amp. Lee Coupland says, if an amp is capable of being used at 18 volt and 14 volt is used as most run 14 volt, does that mean that the components of the amplifier at 14 volt are hardly being used at their capacity? No. At 14 volt, the amplifier will be designed to be in a very optimum kind of, in a very safe, playable zone. It should last a long time. The more voltage you plug into these components, the nearer you get to their limit, they won't last as long. So although an amplifier might be able to be used at 18 volts, the components will be run much harder and it may not last as long. It's not a Sundown. This is a Solid Audio F2500D. I'll pioneer good quality for cars. Some of their stuff is pretty decent, yeah. Chevy says, I sent an awesome song to jam when you're done with the live streams, my brother. It's in your email. Awesome, thank you. I should check that out. I do like it when people send me songs. My cameras are great. My cameras, I just bought these Logitech webcams from eBay for like £9 used the other day, so I could do these live streams. So I'm glad you say that they're good because they were super cheap. What's the purpose of the large capacitors in the amplifier? These are to smooth the power supply switching frequency. So the power supply switches at about 25 to 30 kilohertz. These capacitors are rail capacitors which smooth out the switching frequency so that the amplifier section doesn't hear or doesn't get affected by the switching frequency of the power supply section. The big ones all along here are the output capacitors. So they're a different purpose to the rail capacitors. So yeah, right, let's get started on this then. So the first thing that we need to do with this one is we need to, we always work on the power supply section first. So we need to remove all the power supply FETs. And just for simplicity, I'm going to also remove the rectifiers so that I can isolate the power supply section from the output section. Actually, no, fuck it, I'm not going to do that. I'm going to remove the driver board. This driver boards are on headers, which makes for an easy repair. And I'm going to remove all of the power supply FETs, and I'm going to remove all of the output section FETs as well, because these are 9640s and 640N FETs, and I'm going to replace them with 12P20 and 19N20D, because they are much better FETs for this amplifier, I think. So let's get started with removing all these dead, janky ass power supply FETs. Power supply FETs. And I'm not going to bother, I don't think I'm going to bother salvaging any of them. Actually, some of them could be alright. Fuck it, I'm going to salvage some of them. I'm going to snap off these ones that are obviously dead. And if any of them have survived, then what I'll do is I'll use them when I'm doing the single FET power up in amplifiers when I'm testing the drive circuit. Because then if they die, I don't care, because they haven't cost me anything, because they're donors. So wiggle these off the board. Wiggle, 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 wiggle. So you see what I'm doing here? Where I'm wiggling these FETs off the board. If the board isn't screwed down to the heatsink and the board flexes when the amplifier is being used, when it's mounted to the box, then this is actually what happens. 50 times a second, it snaps the legs off, and so that's how you get vibration damage in a lot of these amplifiers that aren't screwed to the heatsink down the middle of the board. This one, luckily, is screwed down to the heatsink down the middle of the board, so you don't see many solid audio amplifiers with vibration damage related issues on the FETs and rectifiers, which is good. It means that the designers thought about it. Is the amp yours, or are you fixing it for a friend? Neither. This amplifier repair is for a customer, because this is my main business. This is my bread and butter, my friend. So this is for a customer. So all I'm doing first of all is I'm just putting some fresh solder on these pads, because it'll help the solder get pulled out easier without pulling the vias out. I'm just applying a little bit of fresh solder just to mix in with the old solder, and it allows it to pull out easier. Now I say solder with the L, and I know Lewis Rossman says solder, but I feel like in order to say solder you have to have an American accent, because saying solder in a British accent just sounds weird. It does to me anyway. So if I was just being like, oh yeah, what's up guys, let's just apply some new solder, to me that sounds weird as fuck. So I'm not doing that, I'm saying solder with an L. I remember a week or so ago when you said you were repairing the Vibe GH amplifier. There's one sat in on my floor in Protect. Says Matt on the live chat. Yeah, I do have a Vibe Class GH that I'm repairing, but it's proving to be a bitch of a headache. So yeah, that one's still on the to-do list. I've ordered some new parts for it and I'll come around to fitting them shortly, but it's not a massively high priority amplifier. The customer who I'm repairing it for is also a distributor, and he said no rush with it. It belongs to him now, it's his own amplifier, it's not for a customer or anything, so I don't have a time frame as such to work on that, and I'd rather not rush it. So I'll get around to that one in my own time. What do you think of the DS18 Hooligan 8K amp? I don't know. I haven't seen it or used it, but I can tell you now that DS18 will not have had anything to do with the design of that amplifier whatsoever, because DS18 are just a sticker brand. So what I mean by that is they don't actually make anything themselves or design anything themselves. They go to factories and they make huge, large quantity orders of standard factory components, amplifiers, subwoofers, etc., and they put their sticker on it, they put their brand on it. So as long as the factory that they got it from is good, and as long as they've chosen a good tier, a good quality tier in the factory, then it should be fine. But I'll need to check out the board to see whether it's a Chinese board or a Korean board or wherever it's come from. I mean, you could completely prove me wrong, and it could be that DS18 actually has employed somebody to design them a unique amplifier in this case, but I doubt it. I highly doubt it, knowing DS18. What books did you read and or videos did you watch to start learning amplifier repair? I pretty much learned mostly by trial and error. So I bought some amplifiers that were blown, and I just sat there and saw how they worked and saw what was not right with them and how to fix them. One of the best things that you can do when you're actually starting out in repair is buying, so if you have a blown amplifier, I would highly recommend you buy the same amplifier but that works. And what you can then do is you can compare voltages and resistance readings between the blown one that you've got and the one that works. And by doing that, you can see where the common faults are in the amplifiers. And that was one of the best things that I actually did, was to have a working one and a blown one at the same time to study. I did also buy Perry's Amplifier Repair Guide from the BCAE 1 website, Basic Car Audio Electronics 1 website. Perry's Amplifier Repair Guide is phenomenal. It is full of, it's about 4 or 5 gigabytes worth of amplifier repair guides, and 4 or 5 gigabytes worth of HTML text is a flipping lot of information. So if you are interested in reading up on amplifier repair, I think it costs something like $40. It's worth every single cent or every single penny of that money to buy the amplifier repair guide from his website, because it is so in depth and there's so much that it covers. It's a little bit outdated now. It doesn't cover a lot of newer amplifier designs, but it teaches you all the basics, teaches you everything you need to know to start repairing amplifiers. And so that, combined with my own research and my own trial and error, messing around, plus the additional aid of some very good friends here in the UK, some repair techs in the UK, that's how I learned. And I've only been doing this for a year, so I'm not, I'm not like mad experienced, really, compared to a lot of people. But I feel like I have a connection with electronics and how they work. I feel like I can understand electricity and what it wants to do. So yeah, I kind of learned quite quickly in that sense, I guess. This one's being a bitch. Now, because the problem is, because this amplifier has been repaired so many times before, all the pads and stuff, they're not making a great connection down to the board anymore, and all the solder joints, all the pads are kind of janky. So removing all these old fetches is a bit of a headache. Is it worth trying to repair, says Matt. Matt says, is it worth trying to repair the Vibe? Yeah, I'd say so. They're actually really nice amplifiers. I do like them a lot. They're just a bit of a headache. I just need to work out what it is that's not happy with. Because it's basically a Class AB that then goes Class D at full output. So it should be pretty simple enough, but it's a bit of a headache. I can't seem to find the fault. There's a fault in the output section. It's pulling excessive current, and I can't work out why. I'll find it in the end, though. Are the new Orion SP or X amps any good? Not sure. Haven't seen them. Sam's a businessman and a friend to share his knowledge with us folks. Can't reach him to repair our amps. Huh? What's that? Chevys, not Hondas? Not sure I understand that. What do you think about Vibe in general? I don't like Vibe in general as a brand. I don't like Vibe. They've copied a lot of really decent stuff, and they charge a lot for stuff that is very mediocre. I'm not a huge Vibe fan myself. They have made some very nice products, so don't get me wrong. They have brought out some very nice stuff, I just don't like their business model, and I don't like the people that work for them either. I don't like the people that work for Vibe in general. A couple of the people I don't like. I just have a very negative, sour opinion of Vibe. Not a huge fan. What else we got in the chat? I noticed my Class D amps have trouble creating 7 Hz on a tone generator, but it can do the 7 Hz pulses just fine with Bass I Love You. Why is that? I didn't think Bass I Love You was 7 Hz, was it? Oh no, the first one is probably, yeah, the first one probably is. It might actually be to do with your signal generator not liking the low impedance at that low frequency of the preamp section. So check that out. It might be something to do with the signal generator. Have you heard of Soundstream? Have you done repairs on them? Yes, I have heard of Soundstream. I've done repairs on some of their old school amplifiers. Some of their stuff was okay, you know. Some of their stuff was kind of cheap and shitty, but some of the stuff was alright. I repaired a Tarantula. I repaired a Tarantula 2K 2000 something, I think it was. And the old Soundstream amplifiers, like the Tarantula, are very, very fussy with what FETs you use in the output section. You can't replace them with just anything. You have to use the original FETs, and you have to use the original drivers, because they're very, very fussy. It's a really janky old Class D design, and it uses a series of transistors to sort out the Class D switching frequency. And it's very janky, and it's very fussy with what parts you use. So if you're repairing any old Soundstream amplifiers, use original parts. Don't try and replace them with anything modern. This is taking fucking forever. I think I'm just going to cut the legs. This is taking far too long. The solder's not coming out nicely either, because the top of these pads has slightly come away on the top of the board where it's been repaired so many times. So I think I'm just going to cut the legs off. Screw it. I've got loads of 064 ends sitting around. Yeah, fuck it. Let's just cut the legs of the rest of them. I can't be asked for that. I always see you scope to check the drive circuits, but for us who don't have one, can it still be done with a multimeter? No, not really. I mean, you can compare, if you've got a working version of the amplifier, you can compare the exact accurate DC voltage on the drive waves, but if the drive wave shape is just slightly the wrong shape, but the same voltage and everything, it'll actually show up as the same voltage on the multimeter, and so you won't necessarily be able to tell just from looking at the voltage of that wave whether it's good or not. So for doing amplifier repair, a scope is absolutely essential in my eyes. I don't think you can do amplifier repair successfully with amplifiers that have serious faults without an oscilloscope, but that's just my opinion, because you need to be able to see the shape of those drive waves. You need to be able to make sure that it is rising quickly to turn the FET on, and then it's falling quickly to turn the FET off, and that there's no dips in the middle of the drive. It would be an absolute nightmare if I didn't have my scope, put it that way. It only puts out about 2,000 watts, says Matt. That's the Vibe GH. Yeah, I know it only puts out 2,000 watt, but it's a very nice 2,000 watts, because it's pretty much a Class AB that then switches at its high output. It's actually a really nice amplifier. So, you know, if it costs me a few hours and a bit of money to repair it, and someone else gets use out of it, and I can make a bit of money on selling it, no. What am I talking about? This one belongs to a customer. Obviously, I'll charge him for repair, but I would like to. Obviously, this is the first Class GH amplifier that I will have ever worked on, and will have ever repaired. So I don't mind spending a bit extra time on it just to understand how they work, because I quite like to find the fault with it. I quite like to find the fault with it so that I can then know for future reference what is the fault with that amplifier. So I don't mind spending a bit of extra time on it. That's a problem for me. You see, the problem is I'm a problem solver and I hate it when I can't fix something. So I'll spend stupid, ludicrous amounts of time on an amplifier that really isn't worth the time just because I don't want to get beaten by it. I don't want to get beaten. I'm a problem solver. I don't want the amp to win. I want to be like, yeah, in your face. You're making bass again, you know. I don't want it. I don't just want to be like, ah, fuck it, you know. This amplifier, it's a nice board, but we're gonna have to chuck it. We're gonna have to throw it in the bin, or we're gonna have to use it for parts. Because I want to get it bassing again, man. It deserves that. It deserves to be working again. It didn't do anything wrong. It got abused. It had bass boost turned all the way to the right. I don't know if it did, but. How much is your customer paying, or are you going to pay when it's done? The customer pays when it's done, but this one will probably be around about a 150. 150 pounds, that is, I imagine. We shall see what else is wrong with it. But this is quite a hefty involved repair, and it takes a fair bit of time because the drive section is dead on this amplifier. So yeah, we need to spend some good time on this, and we need to have some good knowledge about how the drive circuit works. So this amplifier will be, unfortunately, not a cheap one. Let's see what else we've got going on the live chat just real quick. A lot of them go wrong like that. They pull a lot. Yeah, I think the Class GH, when they die, they just pull a shitload of current. How good are this Brazilian amplifier like Taramps or Stetson? Price is alright, or just pay extra and go with big brands? They're very good, but they are not quite there yet with reliability. Out of all the brands, Banda is the best designed, but I think they have issues with where they're getting their FETs from, so I don't necessarily trust them. But I would say Banda's probably your best bet. Just don't buy the Viking 7K or the 8K at this point in time. Have you ever repaired a Soundstream Rubicon? No, I haven't repaired a Soundstream Rubicon. I don't know. Would you rather repair a Class D than Class AB? Class D is harder to repair, but I have more experience with Class D, so I prefer repairing Class D. Personally. Class AB is technically should be easier to repair because it's just a series of transistors that amplify the signal one after another. Blah blah blah. It should be a simpler repair, but I have had more headaches with Class AB amplifiers than I have with Class D amplifiers, so I prefer Class D myself. I'm sure as I get more experienced, I mean I've only been doing this for a year, I'm sure as I get more experienced I shall probably end up preferring Class AB, but I've repaired more Class D and I'm more familiar with those, so I prefer Class D. So we've almost removed all these FETs and we're just cleaning up the holes, so now we can check the drive wave to see whether it looks good on these pads. I imagine we should probably change the drivers anyway, but I'm going to show you what the drive looks like of the original ones in case it's bad, so you can see what it looks like. So you can see what it looks like if it needs to be replaced. Suck in the holes of these pads. On the Soundstream, do you have videos? No, I don't have videos of the Soundstream that I repaired the Tarantula because this was way before this was before I even put up my first amplifier repair video on YouTube, I think. This was way back. This was when my workshop was around in the other configuration. And the issue with the Soundstream Tarantula was vibration damage. So if you have a Soundstream Tarantula 2K, the TA 2000.1 or whatever it is, do not mount that thing to a box because it does not like vibration, because it's not built very well. The board isn't screwed to the heatsink down the middle, and so it acts like a trampoline and it bends and wobbles the legs of the FETs that are mounted along the edge, and eventually they die. They snap off. Okay, so we have removed all the power supply FETs. Right, let's get back to this and see what we've got going on here. Boop, 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 boop. What happened to your solder sucker tip? It's crap. The solder sucker tip sucks. You suck like 3 holes from it and you have to dismantle the whole flipping thing to clean it out. It takes ages. So that was a wasted investment, and that was a wasted time hacking it onto my station. But oh well, there you go. So let's have a look. So as we can see in this board here, I'm going to switch back to my zoom in camera over here. Let's get this lined up. Ah, what's wrong with the zoom in camera? It's frozen. Why is the zoom in camera frozen? That's not good. JVC2. Let's see if I can unfreeze that. Time leak video capture. Huh. Zoom in camera is dead. Still looks alright on the actual camera itself. I might just have to leave the zoom in camera for you guys, unfortunately, because it doesn't seem to want to work. I'm just going to see if I can fix the zoom in camera just real quick. I'm using OBS for the stream, yeah. It's been pretty good so far, but it's got some issues. I've had some crashes and it kills some of the video feeds from time to time. Yeah, it doesn't like what's going on with this. I think the HDMI lead might have. I think the HDMI lead popped out. Yeah, the HDMI lead actually popped out of the back. That's what happened. There's me blaming OBS, and it's just my HDMI lead that popped out the back. Okay, JVCs, put that back down the bottom. I'm just sorting out the zoom in camera for you guys. Give me 1 sec and we shall be sorted with the zoom in camera. I need to just re-add my filters because it looks a bit dark at the minute. So I need to go color correction, color correction. I need to whack up the gamma, whack up the contrast, or whack up the brightness a little bit. Whew, that's a bit too bright, isn't it? That's a bit too bright. Let's turn that back down a bit. Screw it, that'll probably do. Brightness. Okay, there we go. The mic has changed on that scene again. Oh yeah, it has. Which mic sounds better though? Okay. Right, that'll do. So yeah, well, let's have a look at this. So we've got our power supply drive circuit is in the middle here, and it looks very familiar to those who know what these look like. So we've got the TL494, and this is the TL494AP, which is the standard stuff. And we have the pins 9 and 10, which is sending the drive wave to these 2 driver transistors here. And then these are the ones that buffer it before going to the final 064N MOSFETs. So we've removed all of the 064N. So what we want to do is just see whether these drivers are shorted at all. Actually, I can see already one of these is bulging. One of these is bulging, so that's definitely going to be shorted or something. Yeah, we've got a 220 ohm resistance between a couple of those legs. And this one is also bulging. I'm not sure if how well the camera can make that out, but we have, yeah, that one's definitely visually blown. So we need to replace those 2 drivers as well. Now, when the drivers die, sometimes it can kill the 494. I hope not in this case, but sometimes it can. It's not a big deal if it does, we can just replace the 494. But we need to pull these drivers out now because they're visually damaged. But I wonder if I can show you guys what the drive wave looks like when it's bad. Let's hook it up to a power supply and show you what the bad drive wave looks like, out of interest. You're in the UK? Yes, I am in the UK. Condenser mic sounds way better. Is that the one that I'm currently using now, yeah? That's good if that's the case. What are your favourite subs and amps, if you don't mind me asking? B2 amplifiers, digital design subwoofers, B2 subwoofers, Tantric Audio subs looked awesome. I never actually got my hands on them, but they just look fucking badass, man. I mean, come on. Genesis amplifiers, oh, beautiful SQ, Moscone are beautiful. There's a whole range depending on what I'm after, really. I'm just going to apply some power to this board so that you guys can see exactly what it looks like when the drive circuit is bad. Actually, before we do that, we've still got a short circuit on our power terminals, you can see here. We've still got a dead short circuit across those, so I might have a solder bridge, which we need to check for on these pads from desoldering. We either have a solder bridge or one of the drivers is actually dead, and that's causing a short circuit across the power. No, it's not that. So we've probably got a solder bridge. Always check for solder bridges. It's very important because it can cause more issues than you realise. So we just finished desoldering these, so we might have a solder bridge between a couple of these pads, which is causing there still to be a short circuit across the power terminal. So let's just go along with our iron, just make sure that we don't have any solder bridges between any of these pads, because that can cause issues. Okay, let's see if that fixed it. Let's get our multimeter. My negative probe is about to snap off. Okay, so we still have a short circuit across the power terminals. So why is that? Is there a solder bridge on the top of the board? Let's have a look. Yes, there is by the looks of it. There's all sorts of solder going on top of the board. So let's work our way across the top of the board. See if we can get rid of any solder bridges that might be occurring here. Another thing that might have happened is it might have actually killed the reverse polarity diodes, which can sometimes happen, and that might also be why we have a short circuit across the power terminals. Right, let's see if that sorted anything. Yep, there we go. So wherever the solder bridge was, we just fixed it. So there must have been a tiny little hairline solder bridge across some of those pads. I couldn't even see it. I just moved my soldering iron across there just out of habit. I couldn't even see any solder bridge there, but there obviously was one because now we don't have a short circuit there anymore. So that's just how small they can be. I'm just going to quickly repair my probes here. They're the worst quality probes in the world, and they always have little snaps in them. So I'm just going to use some digital designs, CA glue, and I'm just going to spray the activator to repair that bit of wire. There we go, and that is now repaired. Okay. So let's hook some power up to this, and you can see what the drive wave looks like when it is bad. Bad drive wave, no. Down, boy. You need to clean the circuit. I do need to clean the circuit, yeah? We'll do that shortly. We should do that shortly. I have my alcohol and my toothbrush at the ready. Do not fret. Okay, so got our scope up, this scope was one of the best purchases I ever made. If you're ever looking at getting a scope, I would highly recommend you check out the HP 54602B. That's 54602B. It's a wonderful scope for beginners or amateurs and people starting out in amplifier repair. It's actually got more features than you'd need for amplifier repair, but it's good. It allows you to play with things, and it even has Tetris built in. Check this shit out. Check this shit out. If we go to utility and we hold down 1 and 2, you can play Tetris. So yeah, if you ever get bored in the workshop and the repair is screwing you over, you can go ahead and play Tetris on your scope. But whenever you play Tetris, it resets all the flipping settings. Ah, that's annoying. Why did I play Tetris? Reset all my settings. Damn it. Never mind. Reject low frequency, noise rejection off. DC coupling. Number 1, I've got to go to voltage. I've got to set my voltage for source 1 VRMS, and then frequency, and then voltage source 2 VRMS. Okay, back in business. Display, grid on off. Peak detection normal, position. How do I turn that bullshit off? I shouldn't have played Tetris on my scope. Cursors, here we go. I can turn my bloody cursors off. Clear cursors. Source, clear cursors. There we go. Back in business. Ah no, don't want cursors. Stupid fucking. Don't play Tetris on your scope if you. VRMS 1, VRMS 2, VRMS 2, VRMS 2, source, there we go. Okay, there we go. It's back to how I like it. Cool. Right, let's show you what this bad drive wave looks like. So, as you can see, we've got we've got 9 volts there ready for us on the center pad of our MOSFET pads here. So if we check the gate now, we've got nothing, and if you apply the remote, let's see what we get. So this is our drive wave switch frequency. Let's show you the scope fully. So this is the drive wave switch frequency, and this is on the gates of the power supply section. So we're going to go ahead and see what all of these look like. These ones looking okay. These ones are looking okay. Aha! Look at that. So this is on one of the other banks. So if we probe this one, you can see this is what the drive wave is meant to look like. And on one of the banks that died, this is what the drive wave looks like on the dead bank. So you can see there that we have the drive wave that is riding along DC voltage. And the reason it's riding along DC voltage is because the driver transistor in the middle of the board is actually leaking some of its DC voltage through to its output pin. So that one obviously needs replacing. Let's go over the other side and see what the drive wave looks like on the other side. We have good drive on here. That looks mostly okay. And the same case on the other side. So we've only got 2 drivers, so it looks like only one of these drivers is bad. But they both showed signs of bulging, so we're going to replace both of them. Let's turn our power supply off. And flip this bad boy over. And we're going to get to soldering or desoldering the driver, which is here. I'm just going to use my zoom in camera to show you the soldering. So there is 2 banks on each side of the amp. Yes, there is. This has, well, yes, it has 4 banks of power supply FETs, but they are driven by only 2 drivers. It only needs 2 drivers because we have, on this amplifier, we have a square wave in one phase and a square wave out of phase. So we have a 0 degrees square wave and a 180 degrees square wave. And that's how the power supply is driven, and that's how it drives the transformers with the 2 banks. That amp has a nice power supply. It's not bad. It's not that great for a 2K, 2.5K, but it's okay. It's not bad. If anything, I would like to see a couple more drivers on here. It could do with 4 drivers, really. But yeah, it's not bad. What's the most common amplifier repair? What's the most common amp failure you see? Clip, lol. No, not clip. Not clip. The most common amplifier failure I see is vibration damage. Most of the time, amps wouldn't actually die if they didn't have vibration damage. Honestly, so many amplifiers would actually be fine if they hadn't been damaged by vibration. So we're just sucking the holes out of all of these driver transistor pads here. Now, this is some pretty old solder, so I'm just going to apply some fresh solder in here so that it all comes together nicely and sucks out easily. That's better. There we go, there's one. We're just doing this very carefully because these the pads for these driver transistors aren't the strongest of pads, so we don't want to pull the vias out and make it harder for us to replace the new drivers, and that's the second one out. Just whilst we've got the drivers out, I'm also going to check to make sure that the 494 IC chip isn't the thing that was actually damaged there. I don't think it was. I think it was the driver transistors, but it's always a good idea just to check the 494 whilst you've got the driver transistors out, just in case. Why can't the manufacturers do something to help the boards from vibration? Because it costs too much to implement something like that. Some brands do. Some brands do make actually very good precautions for vibration damage. But most of the time it's about making sales of amplifiers, and you know, a year or 2 years down the line when they die from vibration damage, they're not too not too worried. They've already made the sale 2 years ago. It's not going to come back to them. So if they can make 40 quid per amplifier more at the time and make them less strong to vibration damage, but they make more money at the time, that's definitely better for them than to spend the extra 40 quid and make less money per amp, or maybe sell less because they're more expensive but have them last longer over a 2-year period, for example. It's just stupid business. Found some of the cheaper amps use little black foam blocks from the middle of the boards. Yeah, they do, but they don't prevent the amplifier from vibrating upwards. They just prevent it from being pushed on downwards, but it still moves up. And also those foam things compress, and when you think about 50 Hertz, this thing's vibrating at 50 times a second. You need a screw, you need a solid screw. Okay, so let's just check the 494 chip. Let's see whether that survived. Let's apply some remote power again. Let's put my ground lead back. So to check the 494 chip survived, what we need to do is probe pin 5, which is one of the important pins to probe because that displays the triangle wave. It would help if I plug my power supply back in. There's a nice looking triangle sawtooth wave, sorry. So we need a sawtooth wave on pin 5, and that shows that the IC is operational. And then we need a nice looking square wave on pin number 9 and a nice looking square wave on pin number 10, which we do. Let's just check that those two pins are equal. Yep, both of those square waves look exactly the same. So this IC is doing a good job. So that's fine. Good stuff. Now, let's put the drivers back in. So what we've done now, we've removed the two drivers that were dead. These two drivers are kaput. They both are bulging and look pretty janky. And both of them are, these are both a PNP. So this is a B772 transistor. So all these do is these just pull the wave down. So the square wave gets sent from the 494 chip in here. Let's switch my camera up a little bit. So yeah, the wave gets sent from the 494 chip here, and it goes through these PNP transistors before, as well as going to the gates on the amplifier, on the power supply MOSFETs. And the reason that it goes through these PNP transistors is so that the wave gets pulled down quickly and sharply, so that the MOSFETs turn off very quickly, because they need to turn off instantly so that the other side can switch on instantly as well. And that is the only purpose of these ones. Some amplifiers you'll find will have a NPN and a PNP driver, and the NPN buffers the wave and the PNP pulls it down, but in this case we just have the pull downs. So I'll pop these in here. Nice little PNP. That sounds like a 50 Cent song. I don't know what you heard about me, but I'm a motherfucking PNP. I'm a PNP. Okie dokie. Let's push these through. Pop. There we go. Solder these in place. On your personal amplifiers, do you add fans? Sometimes, yes. LW Audio 4-channel Class AB, I have added a fan because it overheats like shit. Depends what it is. Some of them don't need fans. A lot of Class D amplifiers don't really get hot enough to warrant a fan. It depends on your impedance rise as well. But if it's being driven hard, or if it's a Class AB that you're driving hard, then it will overheat, especially in the summer, and it will go into protect due to thermal. So yeah, you can add fans. Okay, let's cut these legs off. Oh, that was all out of shot. That's annoying. Sam, could you test the value of that thermistor and send me the value when the video is over? Mine uses the same one and I don't know the value of mine to replace it. Sure. Let's measure the resistance of that thermistor just now. This is in circuit, so it might not be mad accurate, but at room temperature it's 13.31 kilo ohms, so 13k. If we heat it up a little bit, does it change? It's now 12.7, so yeah, it reduces with heat. But at room temperature, it's pretty warm in the workshop, it's 13 point something. Do thermistor go down often? No, they never die. They never die. If they die, they only snap. Alphard audio amp, beast or what? No generic factory amplifier. No audio research from Alphard gone into those amplifiers. It's just off-the-shelf parts from a factory in China or Korea, which is good in some cases. They do make some good amplifiers in these factories, but they're nothing unique or special. You can find the same boards by different brands, potentially cheaper elsewhere. Just going to clean off the solder flux on these pads we just soldered. Bit of alcohol, bit of toothbrush. Always do your teeth. Okay, wicked stuff. Also going to clean off some of the blackened burnt bits over here from where these FETs died. What about Alphard subs? The same goes again. They're literally just generic stuff from the factory, and Alphard have maybe said, oh, put a bigger coil on this, or do this, that, the other. The motors, however, I think the motors are actually made, I need to do more research on this, but the motors I think motors are unique, but all the soft parts that the Alphard subs use are the same as a DD Redline, for example. So the DD Redline, spiders, etc. is all the same, so the actual soft parts are all made in China, but the motors might be made either in Russia or specially for them in China. The motors are pretty good. The motors are pretty cool actually, it's just the soft parts. Soft parts aren't that great in my opinion on the Alphard subs, but they do get down. They do take some power. They got like 6-layer coils, 6-layer 4-inch coils, so they'll take power. You know, but in terms of like, do I have mad respect for these guys in designing a fantastic subwoofer? No, not really. Not like B2. B2 make their own. You know, they've done fucking years of research on a lot of their woofers, and it shows. The build quality is fantastic, and their unique build quality. Okay, so let's just check those drivers are giving a nice equal square wave to each of our pads. Actually, we need to change the gate resistor. So if we look at the board here as well, if we go to here, can we see that on here? Let me just go along a little bit, push this along. So you can see that there are some little resistors here which are connecting the gates to the driver transistors in the middle of the board. Now these often fry when the amplifier goes down like this, because 12 volts is being sent directly through them to the driver transistors when the MOSFETs die. So what we need to do is we need to go ahead and replace all of these gate resistors because they all look pretty janky. So let's go ahead and do that next. Now I think the 064Ns, I think they like a 47 ohm gate resistor from memory. This is from memory though, so don't quote me on it. Let's check. What do we like? What do we like? 47 ohm? A 22 ohm. Okay, no worries. I think I have some spare 22s. I could also use 47s. 47s would work as well. But I'll see if I've got some 22s to replace with. 10 ohm might also be fine as well. 10 ohm might also be fine as well. What are you spraying? Says Technology. I'm spraying 99% isopropyl alcohol. What do you consider the most durable 1/2 ohm amplifier line? The most durable? Ha! Well, I've got to say LW Audio, because out of the hundreds that I've sold, not a single one has come back needing repair or blown or anything. Not a single one of those amplifiers I've ever found has died. So LW Audio is just a general, it's a pretty generic amplifier design from the Zenon factory in Korea. But I think they've done a really good job on the amplifier board designs, and they're extremely reliable. We've abused the crap out of these things, down at 0.5 ohm, running super low voltage, like 9, 10 volts on some of these amps as well in customers' cars. You know, not purposefully, but when they don't upgrade their power supply enough. And not a single one has died or blown or anything. So yeah, I would say the Zenon style boards like Amplifier Audio would be a really good option for durability. Mainly. And they're good build quality as well. Amplifier got a lot of teeth. What? What'd you say? What amp are you working on and doing? How long does it take for the caps to go in, amps to go bad? Many years. The amplifier I'm working on is a Solid Audio F2500D. This is a very old school Class D 2.5K, and it uses P channel and N channel MOSFETs on the output section with two separate voltage rails, a high voltage rail and a low voltage rail for the audio to swing between, rather than a single voltage rail and taking a reference between the two like some or most modern amplifiers might do, or rather than just using N channel MOSFETs on the outputs. I don't have, LW isn't necessarily my own brand. It's my good friend and business partner in Sweden called Lawrence Vasterson. That's his brand, but I was UK distributor for it, and we've had a lot of business together. We've helped each other out quite a bit, especially with the Banda stuff. He's a very good friend of mine. So Banda was, LW Audio was my baby in the UK, but it's technically not my brand as such. It's Lawrence's brand. He did all the work with Zenon factory to get it up and running, to get the amps made. I just went in with him on the order value, and we got a load of amps shipped over from Zenon. I'm still planning on getting more shipped over, in fact. Can't see what you're doing, scope is in the way. Oh yeah, so it is. My bad. Bambi, run! Yeah. Yeah, that tune gets in my head, especially during this time of year in the UK, because all it ever does is piss with rain. for those of you who recognise the song I was whistling earlier. Right, now that we've removed all of those janky ass looking gate resistors, I'm going to power the board up and make sure that the drive waves look equal to all of those gate resistor pads. So let's bring our scope back in line. I'm just going to change how this camera is a bit, because the scope's kind of in the way a little bit. There we go. Damn, I'm pretty late, says Mitchell Roberts. Yeah man, we've been doing this for a while now. My bro, could you buy it and review Excursion and test the Dayton Audio 8-inch subwoofer? Maybe, but they're pretty expensive to buy here in the UK because there's not an active UK distributor I can really find anywhere for Dayton. So if someone wants to fund me or lend me or something a Dayton Audio 8-inch, then I will do a review, excursion test, do a TS parameter test during break-in so we can see what the TS parameters are before break-in and after break-in. That'd be pretty cool. We can do a bunch of that. So, okay, cool, let's go and fire this board up again, and let's check the drive waves on these gate resistor pads. Got a little bit of DC on there. You see that? It's not quite sitting at ground. And that could be a pull-down resistor issue. These amplifiers have pull-down resistors on these. Of course, and the pull-down resistor won't be connected because the gate resistor is not connected. That's fine. That's fine. So I'm just going and checking all of these drive waves, making sure they all look equal and healthy. Let's pause on this one and jump over to this one. Unpause. And this helps me to see how equal they are. They all look very equal to me. They all look damn near identical. And again over here. Yep, so drive wave is perfect now on the power supply section. So this amplifier is now ready for me to fit new gate resistors and new power supply output FETs. Oh wait, I didn't even have the... My bad! I didn't have the scope on the screen. Just so you can see that again. This is what the drive wave looks like when it's healthy. You can see that there's a bit of DC offset because the gate resistors are not connected to the board. And for the pull-down resistors to pull that little line down to ground to be connected, the gate resistor needs to be in place. So that's why it's a little bit off the bottom there. Maybe if I press number this one, you can see that easier. See, it's not exactly on the bottom there. And that's because the pull-down resistor isn't in circuit because the gate resistor is out of circuit. The gate resistor goes first and then it goes to the pull-down resistor. So that's fine. This looks equal all throughout the board. All throughout the board, so that's all good. Yeah, so this is ready for the new FETs now. Yeah. Buy it from Parts Express. It's 120 USD. Yes, my friend, it is 120 USD, but I'm over here in sunny UK, so I have to pay a horrific amount for shipping on that subwoofer to get that over here just for a review. So no, we're not doing that. If I can find one in the UK that's used, maybe I'll do it. Where is the scope lead connected to? It is connected to the negative terminal of the amplifier over here. My friend, my friend. Now let's see, do I have any 22 ohm gate resistors spare? I've got a feeling I used all my 22s. It's going to be annoying if I did. We can fit 47s for the time being. 47 works fine with the 064N, it's not a big deal. Not in there. Yeah, Lee, I said sunny UK as sarcasm or hopefulness, hopeful thinking, in fact. Actually, wait, hang on a minute. Is this a whole bunch of 22s? I think this is a whole bunch of 22s I've got here. What a mess. Right. I think this is a whole bunch of 22s. Scrap up 22. So that's good. I'm gonna load these up with the original resistance. Yay! Lee Coupland, what are you doing watching my amplifier repairs anyway, man? This must be boring as fucking hell for you. Is this not boring for you? For anyone who's wondering, Lee Coupland in the chat is a good friend of mine, fellow UK basshead, and I've done quite a lot of work on amplifiers for him over the last couple of years. And also, if any of you guys have watched the how to set your gains for two amplifiers identically video that I did, where I used the I inverted the second amplifier's polarity and whatnot. If you watch that video, that is Lee Coupland's system, and he's just ripped it all out again because he was building a wall with the 4 Sundown EV3 12s, I think they were, but now he's changed his mind again. And I think what we're doing now, Lee? What are we doing now, Lee? Are we doing a wall with 4 15s? What are we doing, Lee? Let me know, my friend. I always follow your builds. So you have replaced the FETs and the drive FETs, and now the resistors on them, says Joe ADA. I have replaced the driver transistors, and I'm now replacing the gate resistors before fitting the final power supply MOSFET transistors. This is a pretty standard power supply repair. If a power supply goes down, then you'll generally lose the power supply MOSFETs, of course, and sometimes you'll lose the power supply drive transistors. And if the drive transistors are dead, then you also need to replace the gate resistors. So this is pretty standard procedure so far. Nothing too out of the ordinary. Because I'm here in Norway, it's night time, but I gotta watch your stream. Hey, what's up, man? You're gonna watch my stream, you can watch it tomorrow. I'm sorry that it's kind of late for a lot of you guys. What time is it here in the UK? It's 21 past midnight. And a lot of my viewers are in the States, and so I think it's the evening time. I think it's just after dinner time in the States, am I right? That video of the house party where the bass starts to break the roof is great. Yeah, that's old school. That's very surprising that actually happened. That was an EP4000 amplifier running an old Celestion 18 from Wembley Arena that was removed in a refurbishment. So we're just putting the new gate resistors in place. I'm doing this from the top of the board, which is kind of different. But I like it. I actually quite like this. Top board repair. 620 in Texas. Just tuned in. What's going on, Chris? Good to see you here, my man. Good to see you here, my man. 721 in Florida. You know, I've yet to visit the States. I would really love to at some point. I'm sure I will do in the near future. What I may do is I may try and come over for something like Slamology. Something like that would be cool. Some kind of basshead event over in the States. I'll tell you what, you guys tell me. Okay, you guys tell me. What's the biggest car audio event in the US? The biggest car audio event in the US. What is it? And where is it? What box calc do you guys use for sixth orders? I use Basebox Pro 6. It's not too bad for sixth orders. It does a reasonable job. As long as you know what you're doing, because a lot of the time Basebox 6 Pro will tell you that your box is going to do something and you're like, nah, it's not going to do that. You just got to take it with a bit of pinch of salt and have a bit of real life experience behind you to know what Basebox 6 is telling you is true and what it's telling you is bullshit. A lot of the time Basebox 6 Pro will overcompensate the size of your box. I think it was Basebox 6 Pro was actually mainly designed for much smaller builds and woofer stuff than what we would be using it for. More like hi-fi and home theatre subwoofers and things like that. Obviously, when we're telling it our woofer, what the fuck? Is it still alive? There it is. When we're telling it our subwoofer can take 5,000 watts RMS, Basebox 6 Pro is like, well, let's give it a box the size of a flipping room. Or when I don't know, it's Basebox 6 Pro. Yeah, the box sizes can be a bit weird sometimes, and especially with cone displacement. Cone displacement is not massively accurate, I found, but you can still use it. Oh yeah, Lee's using Vibe Black Death SPLs, but I don't like Vibe. No, I don't like Vibe. You should still get loud with those though, Lee. Don't go to California, it's bad, okay? Lee Sam's gonna go mad on a mad one at you. Nah, that's fine. Use them, break them, fix them. The Black Deaths are okay. They're just they're a rip-off of the Digital Designs 95. The old Digital Designs 95, not the current one. They have some huge events here. Spring Break Nationals in Daytona FL used to be huge. SBN and Slamology are the two that I know of. SBN seems the biggest. So SBN and Slamology seem to be the biggest. Daytona Beach sucks. I used to live there for 4 years. Do you put any polyfiller in your boxes? No. I love budget builds. You break it, who cares? Exactly. That I actually love that about budget builds as well. And that's kind of a similar thing with, like, when you buy an old banger of a car, you buy a car that you don't give a shit about that costs you like a couple of $100 or whatever. You know, it's a bit of a piece of shit, but it runs, and you drive it around like you stole it, and you don't care whether you scuff the sides. And actually, that's some of the most euphoric fun you can have, is having a car that you don't give a shit about and just having a fucking right laugh with it. And you can load it up with some horrific Sony X-Plod bass install, and you got everything off eBay for like 10 bucks each. Amplifiers for like 30 bucks. And you can have the best time. You can have such a great time with stuff that's cheap that you don't care too much about. What's your thoughts on audio pipe? Generally a pipe of shit, but saying that, I recently repaired an audio pipe. I can't remember the model number, but it was a 1500 watt amp. It was like one of their newer ones. Audio pipe 1500 something or other, and it was actually acceptable. It did acceptable power. It made rated power. The board design was okay. It was like one of these modern single voltage rail N-channel MOSFET amplifier board design is really compact, and for the money it's probably quite a good buy. But in general, audio pipe, nah. Apparently the Sony Xplod amps are very clean. Yeah, they are, man. Yeah, the Sony Xplod range in general is actually very misunderstood. It's actually pretty decent. The problem is the Sony Xplod stuff was hella cheap, brand new, and it was sold in like all the Walmart and Halford stores. And as a result of it, all the guys that have no clue about anything audio based would run this stuff. And so what the problem was is that it was run by, you know, by people that hadn't got a clue what they were doing. And so generally all the installs with Sony Xplod stuff sounded like complete whack. And that gave a bad stigma on the brand, because everyone then saw Sony Xplod as like cheap 17-year-old guy driving, no idea about audio, all gain knobs to the right, all bass boost to the right, low voltage, etc. Not have a clue, and generally everything sounded bad, prefab enclosures, all that. But actually the Sony Xplod woofers, if you put them in a decent ported box and you shove some power up their arse, they're very good. And the Sony Xplod hexagonal amplifiers, the grey one that says 1600 watts on the front, actually benches 950 watts RMS at 2 ohms, which is very acceptable because you can pick these amplifiers up for next to nothing. There's actually a guy who did a build, and he did, I think it was, how many? It was something ridiculous, like 12 of these Sony Xplod 12s in a sealed wall in a van type car with like loads of the hexagonal amplifiers on the back. I can't remember his name, but this thing did flipping hair tricks and it sounded fantastic. So yeah, Sony Xplod you can get loud as fuck with, and I will be using a Sony Xplod for some fun and games in my car once I get the power supply sorted. I'm going to throw a Banda 9000 watt RMS amplifier on a Sony Xplod 12, and we're going to see how long it lasts and what score it does. AP1500.1 is the audio pipe amplifier that I was talking about, and yes, Mitchell Roberts, it did do rated power. Avoid the 3K or whatever it is, literally 2 of the 1501s. Okay, fair enough. Do you repair old school amplifiers too? Any chance of videos of that? Yes, I do. I do have an old school Kicker 4 channel to repair. That's very nice. So I'll do a video on that one. Okay, so the gate resistors are all in place now. Let's just check that they're all in place. Yep. So all brand new gate resistors. So just what I'm going to do is, with the gate resistors in place, I'm just going to make sure the drive wave does still look good with the gate resistors, because now the gate resistors are in place, we have the pull-down resistors also to think about. They're now in circuit, so I'm just going to make sure this still looks good. Ah, rare. Okay. So the drive wave, I don't know if you can see there, but it's tiny. It's being pulled down by something, I think, on that one. Right, so let's have a check this out. So on this bank over here, I know the scope screen is in the way here, isn't it? The scope screen is kind of in the way. Let's just move it over a bit. So on this bank over here, after the gate resistor, we have a nice looking drive wave. See, that looks pretty decent. However, over here on this bank, the drive wave is tiny, and that could be due to a dead pull-down resistor. So the pull-down resistor is a short circuit, then it will be pulling the drive down to ground. Let's check, see what it is on all these other ones over here. Okay, so it's on both of these, both of the same bank. We have a bad looking drive wave. So what we're going to do is, to see where the issue lies with that, is we're going to measure the resistance between the output of the driver transistor and ground, and that should be the same on both banks. If it's not, then we have a dead pull-down resistor. So let's spin this round. Maybe you can see that, I don't know. So what we're going to do is measure between the gate here of the good side and ground. Might just put it on 20k. It should probably be a 10k resistor perhaps. So we've got 17. Yeah, I'm just going to remove the power from the board so that it doesn't skew the results, and get ready for a nice spark as we discharge the power supply caps. So between ground here and here. Okay, so we've got about 16 kilo ohms on this bank, and on this bank we have, oh look at that, we've only got a kilo ohm, so that's probably pulling the drive wave down to ground, which is why it looks so small. So if you ever have a drive wave that looks really small, check your pull-down resistors, because that looks like that could potentially be what the issue is here. Now to find where the pull-down resistor is on these boards, we need to have a little look and see. It's either, it could be these ones in the middle of the board. Can I go to the zoom in camera for this? Yeah, okay. So we've got the two drivers here. Now the pull-down resistors could be these two little guys here. Perhaps not. 0.15. 0. Interesting. Interesting. One of these resistors measures 0. I can't see that upside down. 1.4 ohms. And one of these resistors measures 150 ohms. So we could have an issue with a couple of the resistors in the middle of the board here, because these are connected to the drivers here. So we need to check that out, because they are both the same resistor, so we could have an issue there. But let's look for the pull-down resistor on these boards. So we've got over here, we're looking for something that is a high value resistor and that is connected to the gate pads, and then the other side is connected to ground. So let's look, see if we can find one of those. Okay, I'm just going to fire the board up again. I'm going to measure, see what the waves look like on those two resistors in the middle. So just to explain what's going on here, I've had a look at the center of the board. We've got one bank of the power supply FETs. The drive is being pulled down, but only once the gate resistor has been put in place. So what I'm doing is I'm checking to see the difference between these two banks. So we've obviously got a difference on the two banks, and I found these got two resistors in the middle here which are next to the drivers. One's measuring 150 ohms, one's measuring 1.4 ohms. So that could be an issue that we need to look at. So I'm just going to fire the board up and see whether there's any waves on any of these, and whether that is why it's being pulled down. Okay, so you can see on one side of this, yeah, the scope is in view. On one side of this we've got the square wave, and we haven't got the square wave on this one. This one was the one that was 1.4 ohms, and this one was the one that was 150 ohms. So that means that because this resistor is all the way down at 1.4 ohms, it's actually pulling that drive wave down to ground, which is not what we want to do. We want that to be a higher resistance, around about 150 ohms, so that it looks like this and not like this. and as a result that driver will probably be heating up because it's pretty much driving all the way down to ground. What we got in the chat? Would both or one of those resistors affect the drive? Yes, it would do, Joe Adder. It would, in fact, as we've seen, one of them is a low resistance, and so it will. It's pulling the drive all the way down, almost to ground. Your scope must be set on auto ranging for it to cause the pulse width to change like that. No, this is actually the amplifier changing the pulse width of the drive wave. You can see here, as the amplifier turns on, when I hit the remote on the amplifier, the drive wave starts off with a small pulse width and then comes to full duty cycle, which is 50% on these amplifiers. The reason it does that is so that when you turn the amplifier on, it doesn't create a surge when the amplifier turns on, and it sort of slowly ramps up and slowly charges the output section rather than it just being like boof straight away. Yeah, I'm turning it on and off with I actually have a foot pedal for the remote, so I can be using my hands here and just turn the amplifier on and off with the foot pedal, which is really cool. So what we're going to do now is remove both of those resistors, because I don't trust either of them, because they've both obviously been subjected to some issues, some power, and we're going to remove those two and replace both of those with new 150 ohms, and that should sort our drive issues out. Isuzu Pup 1987 says, yeah, I had a friend that had 8 Xplod 12s and 2 Memphis 1000 Class D amplifier in an 86 Cutlass. That was a long time ago and it was loud. Yeah, man, I'm sure it was. That's a lot of cone area. And they're good old woofers, the Xplods. They're good old woofers. So yeah, these resistors here are just responsible for helping the drive wave get pulled down to ground so that the transistors turn off nice and quick. Because we don't want the transistors to be on longer than they should, because that will cause them to heat up. And they should be about 150 ohms. One of them is 1.4 ohms. And so that, my friends, will be causing the drive wave to be pulled down to ground too much, which is why the amplitude of the drive wave looks so teeny weeny. That's one. And that's two. Now, just before I blame these resistors entirely, let's just measure their resistance outside of circuit, just to make sure that there's something else on the board that isn't pulling the that's not causing that low resistance there. So we should measure a 150 ohm on one of these and a 1 ohm on the other one. Let's just put this in view. God damn it! Come here, stay still. Alright, so these might actually be 200 and something ohm, but in circuit they read lower. So we've got a 218 ohm on that one. Aha! And a 218 on that one. Okay, so the resistors are fine, but there's something on the board that's pulling that down. So if we measure the resistance between these two pads, it'll probably be low. Yes, it is. Look at that. So we've got a 1.4 ohm between those two, and these two we've got nothing. So there is some short circuit somewhere on the board between these pads. So let's find out where these pads are between. So this one is obviously connected to this leg of the driver, and this one is connected directly to ground. So there's some connection, poor connection, or there's some short circuit, sorry, between the leg of this driver and ground. And that's this one here. That's this one here. Okay, so let's just go through and check. So this isn't anything to do with the gate. This is something before the gate. So what we're going to do is we're going to follow the traces on the back of the board and see what else is connected to this trace, and then find out where the dead component is. Ah, come on. Okay, that'll do. Let's push that in a little bit. So yeah, so our short circuit that shouldn't be there is between these two pads. This one is our driver transistor for one side, and this is our pull down pads, and we've got a dead short circuit pretty much on these. So what we need to do is look at these traces and find out what else they're connected to. So we need to follow the continuity of this short circuit to ground. So if we put one of our probes on ground over here, which is this one, and the other probe over here, then we just need to follow where this short circuit is going. So let's follow the trace back. It goes to this component here. See, now this is up at 8 ohms. So what we can do is we can actually use the resistance on here to work out whether we're getting further away from the short circuit or closer to the short circuit. Watch. Bring the camera back over here. So right at this place we start at a dead short circuit, right? So that is pretty much a dead short circuit. We've got 0.8 ohms there, and we've got 1.5, 1.6 ohms where there shouldn't be. So if we follow the trace that this is connected to, you can see firstly it's connected up here. Firstly it's connected up here to this one. So on this one we've got the same resistance. Now let's go to the other side. The resistance is gone, so it's not that component. So let's go further down the trace to here. 1.6. Now let's jump over this component to the other side of it. 0.7. Okay, so that is an issue. That's even lower, so we're closer to finding the problem here. Now let's follow this trace and go over to where it shouldn't be grounded. .8 again, and now this isn't 0.8 anymore. So the issue is something to do with this trace and this component here, because the direct short to ground isn't over here. Let's go over to here. So I think we could have a dead 494, guys. So if we look on here, we've traced this back, this short circuit. It starts here where we found the issue with 1.6 ohms. It goes down this trace to this resistor. We jump over the resistor. The resistance gets lower, which means that we're closer to finding the problem. Follow this trace along. The next component is this one. So we jump over to here. Now the resistance is higher because we're now showing a overload on the meter, so it's not that one. So we carry on through the trace and we end up at one of the pins of the TL494. See that? That is pretty much a dead short circuit at the at one of the pins of the 494. I've just realised you haven't been able to see my multimeter. We're just going to have to take my word for it that on this leg here of the 494, we have a dead short circuit where there shouldn't be. So let's flip that over and let's see what pin of the 494 is that. Huh, that's actually pin 9. So that's actually probably what it should be. It probably should be connected to that. And pin 10. But you see, that's the thing though, pin 10. Ah, pin 10 is also connected to that. Okay. So if that's the case, why was that? See, that doesn't make any sense. This is still showing a direct short to ground. So we've still got pin 9. So we've got pin 9 on the TL... Ah, okay. Pin 9 on the TL494. Where's pin 10? Pin 10 on the TL494 is shorted to ground. That, my friends, is our issue. Pin 10 on the 494 is pretty much shorted to ground. So what else is connected to pin 10? We've got a 1.6 ohm on there connected to ground. Let's just confirm that is the issue. I'm pretty sure that wasn't there a minute ago though. We had a good drive wave on before the gate resistors were added. So why has that happened all of a sudden? That's a strange one for sure. What do you guys think? So we had a good drive wave before the gate resistors were added. Now as soon as we added the gate resistors, pin 10 on the 494 has a short to ground. SDB Designs says, awesome work. When a Class D amplifier comes on but no output from the speaker terminals, what might that be? Check the input circuit, check the small blue capacitors on the input circuit and replace all those with standard aluminium capacitors, for example. That might resolve the issue if it's a input circuit failure. Check you have drive waves on the output section. Try and follow the input, try and follow the audio input through the board to try and see where it loses it. So Joe Adder reckons it's a solder bridge. Should we check for solder bridges again? Could be. Could be a solder bridge. I don't think so though. But we'll have a look. It would make sense if it's a solder bridge actually. Because it's something that we didn't have before we worked on the gate resistors, but we do now have after we worked on the gate resistors. So it would make sense. But I did have a look and I couldn't see any. If it's going to be a solder bridge, it will be one of these pins which is next to the ground, which makes sense. Well, I've gone through them and I haven't spotted any bridges. Whether my iron has removed the hairline bridge that's too small for the eye, I'm not sure. Only said since they are close to the FET mounts. Yeah, they're super close. I think there's enough heat to see where the short is, says Mitchell Roberts. I could apply some power to the short and see where it is, yeah. Maybe. Let's just see whether that going along and messing around with my iron has removed that. Be fun if it has. Be really fun if it has. Nope. No, we still got pin 10 shorter to ground. So I don't think it's a solder bridge, because I've just gone through every single one of them. And we also don't have 47 ohms to ground. We don't have 22 ohms to ground on any of these gate pins. Which if one of the gate drivers was shorted to ground, we'd have 22 ohms to ground on the gate pads. Which we don't. It's before the driver. It's before the driver. Bad driver ICs. I just replaced these driver transistors though. They're brand new. They're brand new. Brand spanking new. Unless there's a solder bridge between these legs. I can't see one with my eye. So yeah, it's shorted between these two pins of this driver, essentially. Let's just remove that driver, just in case that driver randomly died all of a sudden. It's brand new though, so I don't see why it would. But let's just see out of interest. Did this driver just die for some weird reason? I'll just remove that driver just very quickly. Let's see whether the short circuit is still there. Rare. No, it's not. So this driver just died? What the fuck? Why did that just die? What did I do? Yeah, look at that! The driver's dead. What the fuck? I've not actually done anything. It's not been driving anything at all. Weird. Okay, well let's just assume that's a fluke. Let's assume that that's a fluke. And let's put a new one in. How strange. There's nothing else on the board that will cause the driver to die like that randomly. And there was me about to pull the 494. 9 volts is too much for it. Trust me. Trust me. Alright, new driver. Again. Yep. See, this is good fun. This is good fun. taking shit out of the board, trying to find issues, to find that the issue is actually with the part that you just replaced. What the hell, guys? Okay, new driver, and we need to put those 218 ohm resistors back in place as well, because they weren't the problem. Even though it looked like they were in the circuit, it looked like they were causing the issue, but they weren't. So you can see how long these amplifier repairs take compared to MacBook repairs. For example, if you watch Lewis Rossman, you can get a MacBook repair done in maybe an hour. And I'm pretty sure this stream has been going for way longer than an hour. And we've not even finished the power supply section yet. We're very close to finishing the power supply section. We've just got a driver that's trolling me. Once we finish the power supply section, we can move on to the output section. Because the output section is the fun part, I think. Right, okay, let's try that again then. Let's try that again. Why did you die, little driver? Why did you die? You should have tested your new driver first, bro. Yeah, all the drivers that I've got in the drawer, I've pre-tested before they went in the drawer, so I know they're all good. Okay, there we go. Let's turn my scope on. So this side that was dead before is now showing correct with the gate resistors in place. Okay, they are different though, you can see. Can you see they're different? This one looks like that. It's a slightly offset on the DC, which we need to have a quick look at. So this one has a slight offset on the DC, and this one is at ground. This one has a slight offset on the DC, and this one is at ground. So we just need to check that out and why that is. It's very possible that I shorted something without noticing it on the board. It does happen. It does happen. It's very possible. So we've got 150 ohms to ground there, that's correct, and okay. Got a 220 ohm to ground, but a 150 on that one. So which one's the one that's at ground point and which one's the one that's not? So these little resistors are playing up. So we've got a nice wave there, a nice wave there. This one is the 150 to ground, and this one is the 220 to ground. Okay, so there's an issue with this top driver still, in that it's not pulling that to ground properly, and that could be this Zener diode here. I think it could be this Zener diode. So I'm going to zoom in here so you can see this again. This board's got a fucking hell load of issues. This board is turning into a right old nightmare. Right. So let's have a look at our drive circuit. Okay. So what we've got here is the two driver transistors. So on this first leg here, we have the input to the driver transistor from the TL494. So as you can see, we have a nice looking square wave input there on this input, and we have a nice looking square wave input there on this one. These two resistors should be reading the same resistance. This one here, which has the good drive wave on this side, which has the good drive wave over here on board, is measuring a 150 ohm, which is about right. This one, however, is measuring a 220 ohm, which is not right. So why would that be? Let's have a look at these diodes here, which are next to the drive circuit. So we've got one diode here. Hopefully you can see that, maybe. We've got a big black diode here, and a big black diode here hiding behind the driver transistor. I'm going to see if I can spin this around, just so you can get a better view of what's going on here. Yeah, so there's a diode here, and there's a diode here. So what I'm doing is I'm measuring either side of the diode. So on the good side, on one side of the diode, we've got a nice sharp looking square wave. On the other side of the diode, we also have a nice sharp looking square wave. On this diode, we have a nice sharp looking square wave on one side, but on the other side, we have the DC offset square wave. Can you see that? So that wave is riding not along the ground, but it's riding slightly higher than the ground, which is not correct. It's not right. So there's still a slight issue we've got here with the drive. We need to check before we go any further. And this is interesting because you might see that wave and think it's fine, but it's not fine. That will cause the power supply section to heat up, and that's not what we want. So what we're going to do is just check the diode continuity between these two diodes, make sure that it's roughly the same. Because it could be these diodes that are dead, and it also could not be. So we're going to measure it one way round first, and we've got a 424 on the meter. If we do the other one, we've got a 428, that's close enough to be acceptable. If we do it the other way around, we shouldn't. Oh, hang on a minute. So with a diode, if you read it one way, you should get a number, and if you read it the other way, you should get infinite on the meter. So you can see here on one way around we've got 429, but the other way around we've got 480 something, which is not right. On the one that's good, we've got infinite one way and 424 the other way, 425 the other way. So that could be the diode is dead, but it also could be another issue on the board elsewhere. So the first thing we're going to do, because we found the issue at the diode, let's pull the diodes and compare the diode specification. Zener diodes are non-directional. These are not Zener diodes, my friend. These are regular diodes. I think they're regular diodes anyway. I can't read what it says on the board. Does it say ZD or just D? No, it's a regular diode. It's not a Zener. It's like a rectifier type diode. It's not a Zener diode. So yeah, these diodes are meant to be just one directional. So let's pull those two diodes and let's read them out of circuit, and let's see whether there's any difference on the pads. Because if we remove them and there's still a difference on the pads, then we know the issue is on the board somewhere. So we're going to suck the solder from these holes of these diodes. These are very tight holes. I may struggle to get these out using just the sucking method. I think I'm going to struggle getting those out, just sucking them and then pulling it through. So what I'm going to do is I'm going to hold the board up like this. I'm going to grab one of the diode's legs from this side of the board using my tweezers, and then I'm going to heat it here. Which one have I grabbed? Top one? I think I've grabbed this one. I'm going to try and lever it out from this side. There we go, it's coming. There we go, that one's out. I don't need to remove these diodes completely from the board, I can just lift one of the legs. And by lifting one of the legs I can measure them out of circuit and see whether one of them is bad or not. Oops. Very tight hole, yeah. Yeah, this thing definitely blew in a catastrophic way, for sure. Said someone on the chat. Guys, I can't go to my my YouTube live stream page right now. Can somebody tell me how many viewers we've got at the minute? Okay, the two diodes are up. So the diodes, even though one of the legs is still connected to the board, they're actually out of circuit now. So what we can do is we can actually measure them out of circuit and see what they read. 53, 54 viewers and 20 people who need to like this video still. Cool. Wicked stuff. I think I saw 112 viewers earlier on an earlier video that I did during the day. So that's pretty cool. Maybe that's a good time to do these videos. Where's my multimeter gone? Right, now let's check to see whether we still have the same readings on these diodes now they're out of circuit. I'm praying that we do, because I don't want to go hunting for more issues on the board. Okay, so we've got 414 one way round, and the other way we've got nothing. On this one we've got 416 one way round, and the other way we've got nothing. So we need to go hunting for an issue on the board. Elsewhere on the board, I should mention. So between these two pads, we still have that. Is that a resistance? Is that a 470 something resistance? Or is that just a diode mode setting? Because the resistance can tell us more than the diode setting can sometimes. Oh wow. So between these two pads we've got an infinite resistance. but we have a diode reading. So that hints to maybe a capacitor being there as well. Wait, what? So we've got 481, and on the other one we've got, so on the pads here, it looks like we shouldn't have any reading between the pads with these diodes out. With these diodes out, we should have no reading between the pads. Yeah, see, 1 and 1, no reading between the pads. No reading between the pads, but on this one, we have some reading between the pads. Okay. So this pad here, this one that I've just removed, is actually the ground pad. So what it means is that we've got some diode thing to ground on this side. So if we go, let's have a quick look. Let's put this on. So we put one on ground. 219, 150. Interesting, interesting. Very interesting. Very interesting. Let's have a look at the bottom of the board here. So these diodes, okay, what do they actually do? What's their purpose? What are they connecting to in between? Let's clean off some of this crap, because that can tell us a lot about what they need to be doing. So one side of the diode is connected to the TL494 output pin, pins 9 and 10. The other side of the diode is connected to the gates themselves. So what it's doing is this diode is being used to null out any indifferences between, it's being used to pull down, or to help pull down the wave. Because by going through the diode, only obviously it's one directional, these will be set up so that it only pulls down on the downward slope. So then it will pull down through the gate. So what we need to do then is check what's going on with this. So if we put one of our probes on ground over here, on the amplifier's ground, and we measure the resistance between here and ground, then we should see our 220 or 115 ohm that we had before. So we've got our 220, which is actually what this resistor is. But on this one we've got our 150. I'm just going to try messing about with the soldering iron here for a sec. I've got a PRS 80 up here on the workbench that I use for music in the workshop. It's good. $220, $150. Where does this go to? This goes to ground. So what else is a resistance there? Man, this is proving to be some bullshit. Some bullshit. This is definitely one of the most in-depth power supply sections I've ever worked on. This is going to be a fucking expensive repair for the customer. This is a lot of work. This is a lot of bullshit. $219, 150. So we should have 150 ohms. But we don't. We don't. I wonder whether the other driver got damaged as well. Which one did I just take out and replace? No, I think that was that one, wasn't it? I'm pretty sure that was that one. Open diode. So we see what diodes we've got going on over here. We've got, so there are some there's some Zener diodes over here on the board over here. Let's compare readings to these. So we've got 622. We've got a 620, 616. That's about right. That's good enough. 622. 534. Say what? Say what? $536. Oh no, 618, that's right. Okay, 618. Am I going crazy? Or did I just see a 5 something on the meter there and it just now changed to a 617? $536 across that small diode. That's right. Yeah, no, none of these Zeners are open. None of these Zener diodes on the on here are open. 534. Okay, what I might do in this case, it might actually be easier for us to find the fault by fitting a couple of power supply MOSFETs, because by fitting the power supply MOSFETs, it might change how the circuit is working, and it might show up the fault a lot easier. So maybe I'll do that, and that might help us find the fault. Just with these diodes lifted off the board, I'm going to apply some power to the board again, and just see where the waves are on the board and see whether that helps me find where the issue lies. I don't think there's a capacitor that's dead. The issue that we've got is that we need 150 ohms on this resistor. This resistor is actually a 220 ohm resistor, but we need 150 ohms on it in circuit. So when it's in circuit, it needs to measure 150 ohms. One of them is measuring 220 ohms in circuit, and it should be measuring a 150. So that means that there's a resistance that is not present, that should be present, that pulls it down from 220 to 150. Which made me think diode, because diodes have a high resistance. They can have a high resistance one way. So that made me think maybe a diode was bad, was open. So let's see what all these waves are doing. So we've lifted these two diodes. So let's apply some remote power. Now you can see what happens without the diodes in place. The square wave doesn't ride on ground. It oscillates around ground. Does that make sense? Yeah. This is the bad side, and this is the good side. Okay. This is very interesting. This is very interesting. So on one side we have a square wave that's still present but it's oscillating around ground with the diodes removed, and on the other side we have a square wave that's not present at all. Very interesting. So because these diodes are still kind of on circuit, I'm going to push them down so that they make contact on the board and see how that changes each side. So if we touch this diode down, how does it affect the wave? Come on. Touch down on that pad. There we go. So you can see as I touch this diode down onto the pad that I just lifted it from, square wave is present. So this is the good one. Okay, this one is operating as intended. We shouldn't have a square wave here on this other bank with the diode removed. The fact that we do means that there's a problem somewhere, and this could actually be a capacitor. So whoever said capacitor it could be the issue. So if we now move the diode down onto the pad of this one, which is not correct, what does that look like? You can see it's jumping around as I touch my hand on it. You can see now when I touch down, it jumps up above ground, which is not right. That's not right. So it's just moving where the wave is rather than getting rid of it completely, or so that's an issue, and that is something that we need to find. See how it's all jumping around like this as I'm touching it? See if that driver you just replaced is still good. Okay, let's probe the drivers that we just replaced. So without the diodes in circuit, what have we got on the drivers? We've got a good nice square wave on that pin. On the center pin we've got ground, because it pulls it down to ground. And on the other side we have nothing. Now let's check this other driver. We have a good square wave, which is the same as the other side. Middle pin is ground. And this one we have a square wave oscillating around ground. So this driver could be bad as well. It could be both drivers that went down. So firstly, let's try removing that then. Let's try removing and replacing that driver. I'm pretty sure that's the one I just replaced though. I'm pretty sure that's the one I just bloody replaced. But let's try it anyway. Let's try it anyway. I'm going to take both bloody drivers out. And I'm going to measure the waves with the drivers out this time. Well, at least this is proving to be a nice in-depth one for you guys. Ouch! That's hot! That's damn hot! Come on, you little driver. Out you come. There we go. I'm going to take both of these flipping drivers out. Let's see what we got going on the board without the drivers in. Okay, so yeah, both drivers are out. So let's see what we've got going on. So we shouldn't have that square wave that oscillates around ground. If we do, we got problems. Let's just make sure there's no solder bridges before I turn it on from my soldering just now. No, no solder bridges, that's good. Okay. So, probe time. What have we got? Okay, so we've got a good square wave on these two, which is what we had before. Now, before we had a square wave that was oscillating around ground. Now that's gone. Now that has gone. Okay, so I wonder if those drivers were just bad then. We don't know, because the issue might only present itself when the drive is being sent to the gates. So I'm going to drop 2, again, fresh new drivers in. And this time, just for your sake, what we're going to do is we're going to measure the drivers on the transistor tester to see whether they're both good before dropping in. They're all brand new, so they should be. So we're going to drop it into the transistor tester here. And wait for it to turn on and show me the money. So, okay, so this has a HFE of 302, IC of 2.8. 302, 2.8. .294, 2.7. That's acceptable. That's within tolerance. So they're both the same. So they should work fine. Yeah, definitely worth purchasing one of those transistor testers. They're incredibly cheap and incredibly useful. Even if they're not like 100% accurate down to the milliohm, the fact that you can measure one that's new and measure one that you've just pulled from an amp, you can see the differences. So you can see whether one's dead or not. So even if it's not the most accurate thing in the world, which they are actually pretty accurate, you can tell differences and you can find dead components with them very easily. And you can also match up the RDS of MOSFETs and the VT of MOSFETs as well on them very easily. Definitely something worth having if you're into repairing with transistors and MOSFETs. .494 is killing the drivers, maybe. The drive wave looks good though. The 494 looks pretty good in general. All the waves look nice on there. So I would be very surprised if that is the case. Let's fit 2 fresh brand new ones one last time. And if these ones still die, then yeah, I'll start replacing other shit like the 494. Just give them a new board. Yeah, if you can find these boards anywhere, let me know. Measure the drivers you just pulled out, please. That is a great idea. That is a great idea. So you can see possibly what they look like when they're bad. So I've got, what have I got? I've got some drivers over here that I pulled out. I've got one. These are one of the original dead ones. These are the 2 I just pulled out. So that is a good idea. Okay. So This is one of the ones I just pulled out that I just replaced. I had repaired before, and so it's no longer a transistor, it's just a bunch of resistors. So we've got a kilo ohm resistor and a kilo ohm resistor. See that? Let's measure the other one. So this is probably the second one I replaced. So probably both drivers died at the same time, but only one of them was showing up as dead. Let's measure the one from the amplifier's original one, the one with the bulge in it, and let's see what that reads as. So that is a single resistor between 1 and 2 of 200 ohms. So yeah, useful bit of kit. Useful bit of kit. And there's me pulling the flipping diodes and all sorts. Right. I'm just going to fit those diodes back in that we pulled up. Because they are probably fine. It's eating them up. Could the soldering iron being used on them for too long have that damage? No, not at the temperature that I'm using it and not for the duration that I'm using it at, no. Isn't it like 2:30 AM in the morning? No, it's 1:30 AM. But I'm often in the workshop until about 3 or 4 AM, so no worries. It's no big deal for me. This is my normal working hours, my friend. That's diode number 1 back in its hole. Now we just got diode number 2. There we go. Resolder. Right. Right. When you're married with kids, these are gold in the workshop. Yeah, they are. Well, I imagine it would be. I'm not married with kids though. I'm just me. Just me. Me and my woofers. Okay, right. Wow. Flipping. Try this again. Okay. Right. Drive. Do we have drive? What does it look like? It's riding on. What the fuck? Unless it's meant to do that. Maybe that's the correct drive. Maybe that's how it's meant to look. Phew, right. All 4 are equal. All 4 drive waves are equal. Let's roll with that. Let's roll with all 4 drive waves being equal. Let's fit some power supply. Let's fit some main power supply FETs. And then we can see the power supply come up and running. But before I do that, before I fit the power supply FETs, there's one thing that I need to do first. And that is, can anyone tell me what I need to do first before I fit the power supply FETs in? What do I need to do before I fit the power supply FETs in? Take a bong hit. Yeah, definitely need to take a flicking bong hit, man. Definitely need to take a flipping bong hit. I'm tempted to have a beer, actually. Tempted to have a beer. Resistors, discharge, vapor up. No, so before we fit the new power supply FETs, the output section is still dead. So if we fit the power supply FETs and the output section is still dead with a short circuit, then we're just going to be driving a short circuit with the power supply, which is no good. So we need to remove all of these output FETs, because we're going to be replacing them with better versions anyway. Now I have two ways that I can do this. I can either sit here and run my iron along each of the three pads until it comes off, which I might just sit and do. Or I can use my large soldering tip and wait for it to heat up, which takes a couple of minutes, and use that. But I think I'm just gonna run my iron along. I'm just gonna run my iron along these. This is actually working and it's pretty quick. There we go. Yeah, this is actually pretty quick. I'm just gonna run my iron along them. Would Class A amplifiers be harder to repair? Yes and no. For me, I'm more experienced in Class D, so for me they'd probably be slightly harder to repair than Class D, but technically they are less complex than Class D, so they should be easier to repair. There's less going on. You're just taking the audio signal and you're just amplifying it slowly, bit by bit, over a variety of different transistors, rather than with Class D. The way Class D works, I wish I could explain this in words. I need to show you guys a diagram of how Class D actually works and how it creates an audio signal. If you buy the amplifier repair guide from the BCAE1 website, Perry's website, then there is a demonstration of how Class D works, and it's flipping brilliant. I would be tempted to show you that demonstration, but I don't have the files on this computer. They're on my workshop laptop. Go grab a beer while the large one heats up. Yeah. The little one's doing its job for me just now. What I'm going to do for you guys, I'm going to get the power supply up and running on this, and then I'm going to save the output section and we're going to tackle that tomorrow. Because it's getting pretty late, and I think that there are probably some people that might like to see this that are sleeping. You need to check into an SSO2 solder sucker. They're made in Japan and very, very reliable and durable, solid aluminium, Teflon tip, etc. Handheld. You can thank me later. Sweet. I'll check it out, my friend. Thank you very much. I always do value suggestions of good kit to work with. Because I did buy a solder sucker, the AOUA one, and it massively sucks, not in a good way, because it sucks up the solder nicely, it heats up the pad, sucks up the solder nicely, but the problem is all the solder gets dumped into a little, obviously a filter canister, and the filter canister just gets so filled up. After you suck like 3 holes, and you have to empty the canister out and clean it, and it takes so long. It takes so much longer to use than just a regular sucker or iron or whatever. Now this is interesting. See this side, the side that survived on this amplifier has never been repaired. These are original solder connections from factory. So this side has never been repaired. So the side that went down had been previously repaired. So it's possible that the previous repair was not of a high enough quality, and this amplifier failed as a result. Because the side that remains active did not die, and so I can actually put these FETs to one side and put them in my drawer as donors, and I can use them on smaller amplifiers because they're absolutely perfectly fine. 9640 and 640N. A match made in heaven. A match made in heaven. Yeah, I'll probably do it in the afternoon. I'll probably start the output section live repair video at about the same sort of time as I started the B2 audio amplifier video earlier today. What's some really old school favourite bass test songs that people can remember from back in the day? What Happened to That Boy was always one that I remember. What happened to that boy? Do, 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 do. Lights Down Low is good as well, isn't it? Put it down on it, lights down low. Lights down low. Ah, who remembers? I'm not sure. I don't think I can say the name of this song on YouTube live stream. Well, the name of the song is Hood, and then Human of Black Descent. There was a System of the Rule remix of that song, Hood N-Word. System of the Rule did a fantastic remix of that song. They had a banging bass line. I remember watching lots of videos on YouTube of that. Let's see what we've got going on in the chat. So yeah, the output produces a wave based on the averages, sort of. That's Class D. Could you try and explain the difference between PWM power supplies and Class D amp power supplies? What? They're the same. It's the same power supply. It's just a PWM power supply. It's only 8:42 in Florida. But it's 7. Oh, okay, so it's pretty early over there in the States. Fair enough. How many viewers have we got? 50 watching. See, I had more viewers earlier, so I'm wondering whether that's a better time for most people, but I don't know. Shy Effect, Shake Your Body. Yeah! Beats for My Van was one, yeah. Do, 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 do. You featured that once. Yeah, I did. So a lot of people can't watch at work. Fair enough. So all of the output MOSFETs have been removed, and I have I have a cough, and I have a little solder bridge here. I'm just going to remove. Always check for solder bridges because they come up all the time when you least expect them. And I have another solder bridge here. Any more? Any more that I missed? Potential solder bridge there. Okay, I think we're good on the bottom side of the board. Let's flip it over. and I'm just going to use my multimeter here on the diode setting to check, just to double check for shorts on the output section between all these different banks. You don't have to go over all of them, just each bank, just check between all 3 pads. No, we're good, we are good in the hood. Let's clean that up a little bit because that's got some janky ass stuff from where that FET blew. Okay, so there's no short circuit on the output section anymore, which means that we are safe to apply some power supply FETs and see what's happened. So let's get some fresh 064 ends. 1, 2, 3, 4, because we've got 4 banks. Now I'm just going to temporarily solder these in place while we're working on the amplifier. I'm not going to put them in their holes properly, I'm just going to temporarily solder them in place. I'm just going to make sure that we have our banks properly. So we've got, this is 1 bank, this is, so we've got banks of 3, so we need 1, 2, 3, 4 FETs. So I'm going to load up, and to do this I'm just going to plonk the FETs on the top of the pads at a weird angle. I'm not going to solder them in properly because I don't want to damage the vias any more than necessary. So I'm literally just going to chuck a ball of solder on top of these pads. The scope is in the way. And I'm just going to pop the, just going to solder the FETs very quickly to the top of the board at an angle so that they are connected but not in the holes properly. And this allows me to quickly remove them if there is an issue. You should visit Oregon. Weed is legal here. Yeah man, it's probably a bit like Amsterdam. I've been to Amsterdam many a time. So I'm fully aware of the what it's like to be chilling out somewhere where there's a pot store on the corner of the street, and it's wicked. It is wicked. I don't smoke weed, or like in general. Like I don't own weed, I don't smoke weed in general. I find my life is busy as hell. I have too much shit to do all the time, and when I smoke weed, I don't want to do anything. And I've smoked weed before where I smoked it and then I've been like, ah shit, I need to do this thing, and then I can't do the thing properly because I'm high, and so then I feel like shit, and I feel a bit paranoid. I'm like, I've got to do the thing, but I can't do the thing because I'm high as fuck. And so weed isn't really, you know, I don't need to be calmed down. I'm pretty chill anyway. And I always have too much shit to do, so weed isn't really for me on the daily. But I went to Amsterdam, and it's, you know, it's fantastic. It's a lovely natural drug to have on occasion when you've not got anything to do. But for me, I have too much shit to do, and it loses me focus. How did you check it was 3 per bank? Okay, so to check the banks, what we do is take our multimeter on diode setting. Okay, now the banks of FETs, so FETs that are in parallel, the gates will also be in parallel. So what we can do is we can put one of our multimeter probes on the gate pad. Maybe I'll do this one because you can see it clearer here on the camera. So put one of my multimeter probes on the gate pad, and then any gates that have the gate resistor resistance between them, so a low resistance like a 43 ohms between the 2 gate resistors, are in parallel. So we've got 1, 2, 3. So these 3 are in parallel. The next one here isn't in parallel because we have a very high number on the screen. But if we measure these 3, 1, 2, 3, these are now also in parallel. So we have a bank of 3, 3, 3, and 3, and these need to be matched in order to work properly. Cool, so we have the power supply FETs temporarily in place, and we have the output FETs off the board, so there's no short circuit on the output section anymore. So this is the first time that we can try and power this amplifier up, and we should get a green or blue light. We should get a green light on the board if this thing works and if the power supply is happy. So let's take our oscilloscope, turn the camera on for you guys so you can see, and we're going to probe we need to get our ground. Crocodile clip connected up, so the scope knows what the bloody hell is going on. So you can see we've got our 9 volts sitting there waiting, ready to go on the middle pin of the power supply FETs. So if we now hit the remote, this should start to come on. There we go. See, that's pulsing. That's pulsing, and that should be charging the output rail. So if we now take our multimeter probe over and let's have a look at the output rails. Okay, so it pulls it down very quickly, but you can see here, the drivers are fucked. So you can see here that with every pulse of the power supply, the output rail climbs slowly. See that? Pulse of the output of the power supply, output rail climbs. Now, if we look at if we look at this is a bad driver. Hang on a minute, no, that's not a bad driver because the driver circuit's out. So what the hell is causing that? This is floating around all over the place. It's probably a diode somewhere else on the board. But yeah, we've got big output section issues as well, guys. We've got big output section issues as well. Yeah, look at that. Why have we got 8 volts on the middle pin? Holy shit, this board's going to be a fucking nightmare. Holy shit, this board's going to be a fucking nightmare. So, look, if we look over here on the correct... sorry, I missed. What pins are we measuring for the same bank? The gate, my friend. We're measuring the gate, which is pin 1 of the MOSFETs. If we have continuity between the gates, or we have, 22 ohms or 47 ohms between them, then they are in the same bank. If we don't have continuity at a low ohm resistance, they're not in the same bank. Between the gate pads, pin 1. Let's have a look at this output section just real quick. So as I'm pulsing the power supply, you see we're pulsing, we're starting to charge the output rail caps. The good side, on the 9640 pads, we should have positive rail on pin 1, a small voltage on pin 2, and a positive rail on pin 3. Okay, so that's on the good side. On the bad side, we've got a positive rail on pin 1, a small voltage on pin 2, and a positive rail on pin 3. So that's correct. Now, the 640N pads on pin 1, we should have a negative voltage, negative rail, which we do. On pin 2, we should have a very small voltage, 2 volts, because there's nothing on the pad. And pin 3, we should have a negative voltage, which we do. On the other side, the side that's bad, we've got pin 1 with a negative voltage, pin 2 with... oh no, that is correct. What the hell was going on there then? Something was messing around a minute ago, wasn't it? You saw it, it was all flying around all over the place. Maybe it's just my probe not making a good connection on the board. Maybe it's my probe not making a good connection on the board. Okay, wicked. So let's go ahead and fire this power supply up fully and see whether we get a green light. There we go, guys. Power supply is fully... that's a full duty cycle. We have a green light on the amplifier. And let's just check the drive waves of these. So this now is the drive wave for the power supply FETs now that they're in. It doesn't look that great, to be honest. That's not the nicest looking drive wave that I've ever seen, to be honest, but it is the same on all 4 banks. It's exactly the same on all 4 banks. As long as it doesn't heat the FETs up, then we're good. As long as it doesn't heat the FETs up, then we're good. So that's been on for a couple of seconds. So let's check the heat on the back of these FETs. They're staying dead stone cold, which is good. So maybe this, I think, to be perfectly honest, I just think that this power supply section is a bit shit. We've only got 2 pull-down transistors, the PNP transistors here, which are BD140s or B772s, which pull down the wave. Usually the best power supplies, the nicest looking, cleanest drive wave signals I see, have a NPN and a PNP transistor that work together and they buffer the wave. But that is the power supply drive wave, and that looks very nice. That's the output of the drive wave. That's the output of the power supply transistors, and that looks very healthy, and it is completely uniform across all 4 banks. Grab the IR cam. Sure, why not? We'll grab the IR cam. But these are absolutely stone cold to the touch, which is nice. We'll grab the IR cam. Let's see. I don't know how well you'll be able to make this out, by the way, because these are pretty crappy little Logitech webcams. So I'll do it this way, maybe take the scope away. So if I look down on FET number 1 over here, FET number 1 is at 25 degrees, 27 degrees. FET number 2 is at 27 degrees. FET number 3, if I move my leg out of the way, is at 27 degrees. And FET number 4 is at 26.8 degrees. So yeah, they're all the same. They're all the same heat, and they actually feel stone cold to my hand. I don't feel like there's any heat on them at all on my hand. They feel like pretty cold. Let's have a look at the output section. Let's just see if anything else is heating up over here. So we should have some small heat around the regulator section, which we do. We've got a small bit of heat around here because this is dropping voltage. But all in all, everything else is staying pretty cold. Everything else on here is staying pretty cold. Do we have any heat? The drivers are just getting to like a lukewarm temperature, 27 degrees again on the drivers. Yeah. I'm pretty happy with that. That's staying very cold. So let's turn that off. Let's just feel with our hand. Yeah, that's good, man. I'm very happy with that. That's staying nice and cool across the whole board. Cool. Power supply section is fixed. That is a result then. So weird. Don't know what the issue was there then with these drivers. Something funky going on. We could have shorted something out accidentally with this soldering iron, but it was good for you guys to see like the process of looking for issues. So that was pretty cool to see. Let's have a look. 54 watching still. Wicked stuff. Now, just for interest, before I shut this live stream off and go to bed, because it's currently 2 AM, what I'm going to do is drop the driver board back in. And we're going to see what the drive waves look like on the output section, just because we've got to this point now. So we can see whether there's any issue with the driver board. So let's drop this back in place very carefully. This is on headers, and we need to make sure that the pins go in the right holes. If the pins don't go in the right holes and there's still any charge left on the rail capacitors, then it could blow the driver board up even more than it already is. So dropping that back in place. Now, sometimes these amplifiers, they won't send a square wave to the gates of these pads without an audio signal present or without the MOSFETs being in place. This is something that's called a self-oscillating amplifier. If the amplifier doesn't oscillate with the MOSFETs out, then it's self-oscillating, which means it needs a complete feedback loop from the MOSFETs to the driver board in order to oscillate. I can't remember off the top of my head whether this one is a self-oscillating amplifier or not. It's old school, so it might not be. It might just oscillate without the MOSFETs in place, which would be nice. So let's fire her up with the driver board in, and let's see what we get. So we're just going to check the rail voltage. Rail voltage is present, 55 volts. Okay, so do we have any drive? No, we do not. So this is the good side. So if this was going to have drive, this would be working. So I think we need an audio signal in order to force this amplifier to oscillate, which is fine. We can do that. We can do an audio signal. So we're going to take our RCAs here, plug her in, line in, turn the who knows what this amplifier was set to gain wise, subsonic off, bass off, low pass, high, phase shift off, master output. Okay, that should be fine. We're going to go to Audacity. I was trying to find Solid Audio websites. No, they're super old. They're flipping old school. I don't think they're in business anymore, so you probably won't find them. Sorry. I'm going to go to Audacity, and I'm going to... Oh, what if I... Oh, yes, I have a screen for this, sort of. You can see in the bottom corner there. So I'm just going to generate a... How many minutes? Generate a 10 minute 50 hertz wave. A 10 minute 50 hertz sine wave. And wait for that to come. So you would see a wave on the output. yeah, you'd see a square wave at the frequency which you shove into the amplifier. You'd see a square wave. How loud is that bass for you guys? Because I think my condenser mic is very sensitive to picking up bass. So we've got 40 Hertz now, there, going in. So let's start that. Okay. Now, I'm going to keep it on this screen for you so you can see the scope. Turn the amplifier back on. Okay, cool. So now you can see, if I change my scope settings, can you see the square wave there? So that is a 50 Hertz square wave riding along the negative rail, which is how the Class D works. So this is the good side. So we've got the good side has the 40 Hertz square wave riding along the top drive. So that's the high side drive. And this is the low side drive. So that's looking very healthy, which is what I would expect, because this is the side that survived. Now if we look at the bad side, let's see what the drive looks like over here. So on the high side drive, that one looks pretty good. Low side drive, that one looks pretty good. Low side drive, that one looks pretty good. And high side drive, that looks pretty good as well. Interesting. So the drive looks okay throughout, across the board. Drive looks okay across the board. I don't trust what's going on the driver board though. I saw on the driver board there was some repairs done to the driver board. Let's see if I can zoom in with my zoom in cam here on the driver board. Where are we? There we are. Okay. Okay. So yeah, on this driver board, how's the quality for you guys on that? It doesn't look that great to me. It looks a little bit blurry. Yeah, maybe that's a bit better. Is that the gate pin you're checking? Yes, that's the gate pin I'm checking. So I don't like, there's a repair here that's gone on the driver board, which is over this side. There's a small hairline wire here which is connecting two of these pre-driver transistors together. I don't know if I trust that, so what I'm going to do is I'm going to power the amplifier up again, and I'm going to probe the drive waves on here, and I'm going to see whether the waves disappear at all when I move the wire around. So if I probe, let's have a look. Let's probe this one over here. So you can see the wave on the screen there, maybe. I'll zoom in a bit on my scope. Nice looking square wave. And I'm going to get my tweezers. Where are my tweezers? Where's my flipping tweezers? Okay, we're not going to get my tweezers. We're going to get a small screwdriver. And we're going to wiggle this wire around and see what happens to the wave. See if it disappears or not. Okay, so it's not disappearing there, it's staying. And let's wiggle it around and probe this side. It's not disappearing, it's staying as well. So maybe that wire's okay, but there will be a reason that this amplifier went down. There will be a reason this amplifier went down. Let's probe this side. We've got our 40 Hertz riding along there. And let's wiggle that stuff around again. See if anything changes. Nope, seems alright to me. That's a previous repair. Yeah, that's a previous repair, yeah. That is a previous. Blurry. Is it good now? Is it good now or is it blurry as fuck? It might be blurry as fuck, sorry guys. I've not got the best camera set up here, I'm kind of making do with what I've got laying around. So the drive waves kind of seem alright. Okay, interesting. So, let's pause that 50 Hertz, that's getting annoying. That needs sear glued in place. Yeah, it does need sear glued. It was sear glued in place originally from factory. So the drive waves all look good. Because the drive waves all look good, what we can do is we can actually risk fitting some outputs onto this board now. What we can do is we can do the same as we did in the power supply. We can fit one FET per bank, and in case they blow again, even on this low power supply, I'm going to use some of the original FETs that survived because they don't cost me anything. So we're going to take some 9640s and some 640Ns, and we're going to fit them in parallel banks, and we're going to see whether the amplifier comes on. I'm actually gonna be a little bit annoyed if this amplifier appears to be working fine when I fit these new FETs, because there's always a reason the amp went down, so I don't trust it. If it seems to work fine, then I'm going to be sitting here scratching my head thinking, oh well, why did this die then? What's the problem here? We could have a shorted inductor, but these seem pretty well seated. I don't think that these inductors are going to be the cause. Okay, that's just what we need to do. Before we touch the soldering iron, we need to wait for this rail voltage to sync. You can see here we've still got, we've got 3 volts on there now. Okay, that's probably fine. So I'm going to fit one 9640 and one 640N per bank. So I'm going to take my friend, my trusty transistor tester again, and I'm going to just check some of these FETs and make sure that they're okay to fit. So we're going to put a 9640 in the tester so you can see what it looks like. So we have a PE MOS, this is a P-channel MOSFET, and we have 3.7 VT, a 1.75 CG, which is gate capacitance, and a 0.7 ohms RDS. So that one's looking pretty good. And let's check some other 9640s, make sure that they are all the same. I want to try and keep the same batch if I can, just for this quick test. Where do you learn all this stuff? Experience and Perry's website, bcae1.com, and you can buy the amplifier repair guide. That one's good as well. We only need 4. I believe there's only 4 banks on the outputs here. Yep, these FETs are all checking in alright. You see they're all roughly the same specs, roughly the same numbers. So let's find one last 9640. That's a 640N, that's a 640N. That's a 9640. That one looks good as well. Okay, so we've got 4 9640s. So let's just double check how many banks we've got on the output section, because we're going to fit one FET per bank for simplicity and to emphasize any heating issues that might occur. So what we need to do to check how many banks we've got on this amplifier, we need to measure resistance between the gate pads. So if we measure between the first gate pad of this 9640 here, which is this, where is it? The gate pads is, what one is it? This one. So you see here we've got a 21 ohm resistance between these 2 pads. So this is a bank, but this next one is not. So you see we've got continuity between these 2, so these 2 are in parallel, but this is not in parallel. So we've got one bank here, but we should also check over here, because sometimes they throw the banks over the other side of the board. Okay, no they don't. Holy shit. Oh man, we've got 8. Oh, we've got 8 banks. Oh, for goodness sakes. Hang on a minute, we've got 3 9640s on here. So there must be another one in parallel over here, surely no? No, I've got 3 bank. Oh, we've got. Ah, no, I think we've got a dead gate resistor, that's all it is. Dead gate resistor, so that's skewing my results. Yeah, we've got a dead gate resistor, I think. Maybe. So we should have 10 ohm gate resistors on this section here. Oh no, that's alright. 9640, 9640, 9640. Yeah, no, sorry, we do have a dead gate resistor here. Yeah, we do have a dead gate resistor, so we need to change that gate resistor before we actually fit these ones. Okay, so yeah, let's change that dead gate resistor first as well. That one is that one there. Yeah, so by checking the banks, we actually discovered a dead gate resistor. But it was obviously not dead enough to completely stop the drive wave coming through. So this is a 10 ohm gate resistor. But what does it actually measure? This 10 ohm gate resistor, what does it actually measure now? Have a look. It now measures 932 ohms. So yeah, that's dead. So this is definitely the gates, isn't it? Brown, black, black, gold. Brown, black, black, gold. Actually, you know what I reckon? I reckon this was repaired incorrectly. Oh, maybe not. Never mind. I'm just going to find which ones are our pull-down resistors. They should be these ones. The pull-downs on the output section should be about 100k. Or, okay, we've got 50k, we've got two in parallel. So we've got 50k on these pull-down resistors. Now the pull-down resistors will stop the gates becoming charged when the amplifier is turned off. So we've got 49, 50k there. 99, 100k there. Oh wow, you guys, I think we've got a dead pad. I think we've got a dead trace. I think we've got a dead trace here, guys. This is unusual and very cool. Very cool. I think we've got a dead trace on the gate. This obviously died in such a way that it killed the flipping trace. That's what I was just looking at there just now, silently. I was just looking and being very intrigued by that issue. Because I'm trying to find the parallel banks, and I was getting a bit confused because there only seemed to be two over here that were in parallel. But I think there's actually a dead trace on this gate. Like the trace, like, has got like a crack blown in it or something. Is that an attachment to the front of your transistor tester? Yes, it is. It comes with it, so it allows you to clamp FETs and parts and stuff in there. Oops, I should probably turn that off. That would explain the funky looking waves earlier. We didn't have any funky looking waves earlier at all, actually. We had pretty good looking waves, which is what's confusing. But I don't think I checked every single pad, so I may have skipped this pad and not checked it, so I didn't see what it was doing. Because we were only looking for good waves on all banks, so I probably didn't check that bank. So I'm just going to grab a spare 10 ohm resistor from my pile over here. Lock that in place. There we go, 10 ohm. These 10 ohm resistors that I've got are actually higher power than the ones that were in there before, but it doesn't matter. You can replace a resistor with a higher power one, and it's fine. So R270 here, this is a gate resistor. Let's get that back in place. See, why am I starting on the output section? I said I was going to do that tomorrow. So yeah, this is still not in parallel with each other. So you see here, we should have these three here. These are 9640s. I wonder if I can zoom in with my camera here so you can see. I need to be on the here. Okay. I'm just trying to get my zoom in camera for you guys so you can see that a bit easier. Okay, so yeah, we've got 3 pads here. 9640, 9640, 9640. So these should all be in a parallel bank. So all the gates, all the gate pads for these banks should be together. They should be linked. So if we check the first two, gate pad, it's linked. We have continuity on the multimeter that's going beep. However, this one, we do not have continuity at the pad, but we do have continuity at the gate resistor. So you see that there's a trace here that goes loop, 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 all the way over to this pad. It's meant to anyway, but it's not actually making the connection. You see there's no continuity here between this leg and this pad, and there should be. There should be. So that's an issue, guys, that's an issue. And it's funny because the trace really does look like it's making a good connection. And that is, my friends, so we found the issue with this amplifier. That is the issue with this amplifier. That's why this amplifier went down. The trace obviously got damaged and was making a poor connection, and that must have been what killed this FET. That's so weird though, because the trace looks really I wonder where it loses it. I'm just going to scratch off part of the trace on the top here so we can actually probe the metal itself. I wonder where it loses it. Okay, so it's still connected there at that point. So it loses it. Ah, look, there we go. Now it's making a connection again. So it's extremely intermittent. There's obviously a break right at where the pad is. There's a break right where the pad is. Yeah, look, now I've just run my multimeter probe over it again. It's dead again. We've now got a 142 ohm resistance. Look at this. This is incredible. This is really fucking cool. I'm going to zoom in on this. This is really fucking cool. Come on. Come on, focus. Alright, there we go. I think we're focused now. Oh, yeah, okay, look at this, right? So, this leg here needs to have a connection to this pad here. At the moment, we have 890 ohms. However, if I scratch my probe over the end of it here, a little bit, now we have continuity in a connection. If I scratch my probe over it a little bit more, it might disappear again. It seems to be staying now. Maybe I've pushed that back into connection. But you see how that connection is so dodgy? There's obviously a break right there. That's fucking cool. So what we need to do is we need to run a patch wire so that we have a decent connection to that pad for the duration, and we will remember to do that. That is really cool. So that's what causes this amplifier to go down. Just a single trace not making a good connection. Madness. Okay. Coat it in solder. Yeah, I might do actually. What I could do is I could scratch off. Yeah, because it's right at that edge, isn't it? So I could scratch off the insulation right by here with this, which is what I'm doing now, and then coat the end of that trace in solder, and that would solve the issue. But I don't trust it. I don't trust this trace now, so I'm probably just going to run a patch wire anyway. Yeah, I can scratch off here, and I can apply a big blob of solder so that the solder connects to before where the break is. That would probably work fine, but I don't trust it now. Anyway, let's fit these FETs in place. I need a shitload of them now actually, because I've got a lot of banks. So we've got, yeah. Anyway, back to finding the banks, back to finding the parallel banks. We've got one bank of 3 here. So we've got a bank of 9640, bank of 640N, 640N, 9640. So we've got 1, 2, 3, 4 banks of 9640, and 1, 2, 3, 4 banks of 640N. So we have 4 fresh, nice, toasty, clean. Well, not that clean because they're pre-used, but we've got some good 9640s here. Good little 9640. So we're going to load them up. Load them up on here on the pads, just on the top pad here, because they're not staying here for very long. They're just being used to see whether the amplifier is actually healthy or not, the drive waves are healthy or not. Now let's do the other side. Where do you think the trace broke? The trace broke right by the pad. Right by the pad. That's what we discovered by doing the investigations that we did. Elementary, Watson. Put me in the freezer cause I'm so icy. Put me in the freezer cause I'm so icy. Put me in the freezer, put me in the freezer. Okay, that's our 4 9640s, so let's find times 4 good 640Ns now. That's our 9640. That's a 640M. Let's grab 4 of these and put these on the board. Make sure these are good. So the 640N, we have VT of 3.2, CG of 2.2, and RDS of 0.2. The RDS is very nice on these, I must say. Very nice low RDS. 3.2, 2.2. 3.2, 2.2 RDS of 0.4. That's fine for this quick test. It's double the RDS, but yeah, what the hell. It's fine for this quick test. 3.1, 2.2, 0.4. .2, 2.2, 0.4. Sweet. So we have 4 decent working 640Ns, so let's bang those in place. Just going to make a temporary solder to the top of the board so that they come off very quickly when we work out that the amplifier is actually fine. I don't trust what's going on the driver board still though. I don't like what they've done with the driver board. I've had these solid audio amplifiers in before where the vias on the driver board, they corrode, and so you lose drive as a result. Last one, last 640N, and then we can power this up and see what happens. See whether the thing's alive or not. Right, there we go. So they're all on. So let's just check for solder bridges very quickly. I don't think we shouldn't have any because we didn't really do any hefty soldering, but it's always good to just double check for solder bridges. Nope, no solder bridges. Okay, cool, let's fire up then and see whether we have output switch. We should technically have output switch. We should have a relatively healthy operational output switch because we had good drive wave on all of those pins. I'm just checking the rest of the gate resistors were all 10 ohms there. Okay. Right, moment of truth then. This is the point where the amplifier could power up into full operation. Full Class D switch. Full operation. Let's see what happens, guys. So let's probe. Get our probe and let's go on the. Let's go on one of these. We're gonna have a bit. Oh, that's not right. That's because I haven't put my ground. I haven't clamped my ground thing on the amplifier yet. Keep forgetting to do that. Okay, so we should see a nice big square wave on every single one of the back of these FETs. There we go. Can you see? The switching wave was just about to kick in there. I have my scope on the wrong setting. So the amplifier's trying to come on. It probably won't be able to come on with my 9-volt supply, too small. But this pulsing of operation is actually not a bad thing, because it means that we can check for issues without the amplifier coming full duty cycle. So now that that's been pulsing for a bit, let's check for heat on the back of these FETs. Cold, 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 cold. Cold, 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 cold. So yeah, we're cold all the way around. There is a little trick that I can do actually to get this thing to force this thing to come on, and that is to remove the pull-down resistors that are pulling the main rail voltage down. So you see, if we probe here, you see we've got the rail voltage. So that's 39. Let's change my screen. You can see we've got the rail voltage here. See that? 44 volts, etc. There's resistors that pull that down to ground. You can see it's pulling it down 40, 41, 39, 38, etc. That's being pulled down by resistors, and that just makes the amplifier safer to work on. That's all it is for. And so the pull-down resistors will be somewhere around here. So we can temporarily remove the pull-down resistors, and that will allow the amplifier to come on with a 9-volt supply. But screw doing that, because that requires more soldering. So let's just whack out our slightly bigger 12-volt supply, and let's turn this thing on and leave it running for a few minutes and see if anything heats up. Let's see what we've got going on in the chat. Dual alternators on the Mark IV Astra G. You can put dual alternators on pretty much anything if you go to the right garage. They can put an alternator in the old air conditioning pump location, which is good. Will you move to the States and work for me? No, sorry. It has been hours to work on this pig. How long has this live stream been up for? Holy shit. 3.5 hours this live stream has been active for. Fucking troopers, man. Who's been with me from the start of this stream? From the start of this amplifier? Who's wasted their evening away watching this crap? So we're going to apply our 12-volt supply now, because these things need a little bit of current to come on. Need a little bit more current than my 9-volt supply can give. No way! Lots of you guys have been here from the start. Crazy. Crazy stuff. Well, thank you. Well, thank you very much. I have an intermediary 12-volt power supply, which is this old computer power supply. You know what? Actually, the next thing on my shopping list is a proper bench power supply. I want to try and get HP unit to match my scope. A HP, proper professional bench power supply, programmable power supply that I can set current and voltage on, and that way I wouldn't have to screw around with all these random power supplies and wires and crap. But I'm waiting. The problem is the nice HP ones that I want, they're not. You can't really find them in the UK very often. So I'm waiting for one to pop up at the right price. There are a couple for like £300 on eBay at the moment, but I can't afford them just now at that price. It's not a worthy investment. It won't help my business that much enough to warrant spending that much on it. But I would love a bench power supply. That is the next thing on my list to buy. Matt has been with me since the start of the B2. Yeah, I know you have. I recognise it. That's crazy, man. It's crazy. You've been here for a long ass time. You've been here for a long ass time. Matt, did you do amplifier repair as well, as a hobby or anything, or as a business? Let me know, man. Are you watching this to learn for your own benefit, or just out of interest for car audio and electronics? Also, Chevy's Not Honda's been here since the start of the B2. Can you teach me how to build a high amperage power supply to run car audio in my room? It's not worth the effort. You can buy these things for like 25 bucks that will supply 175 amps at 12 volts, and that's all you need. It's not worth your effort and time building it, honestly. unless of course it's a hobby. But to be perfectly honest, I wouldn't know. I wouldn't be able to advise you how to build a power supply from scratch. I'm not that knowledgeable. I'm not that knowledgeable. I can repair shit, but designing a power supply from scratch that can supply up to 200 amps, switching power supply, that's complicated stuff. Even people that make power supplies, they struggle with these high output stuff. So okay, wicked. We've got our big power supply here ready to go. Let's go back to this screen here. Let's get our scope probe. So this might work fine now. If this works fine, what I'll do is I'll put it back together tomorrow and we'll do a bench test. And let's probe the side that blew. So that's this bank over here. This 9640, that blue. Okay, large power supply, here we go. Will it explode on the bench? This power supply does have enough current actually to make this thing explode on the bench, so hopefully that won't happen. Ta-da! Okay, we have operation. That is a full output switch wave, and it came on very quickly and it came on very cleanly. So let's check for heat now on these FETs, because that was a few seconds of operation, which is all it needs to generate heat if there's an issue. No, they are stone cold. They are staying stone cold. So let's get this thing back up and running. We have a green light. We have full operation. So that's the output switch of the low side. I think that is. No, sorry, the high side. That's the high side. So that's the high side output switch. Low side output switch. Low side. High side. Let's go over to the other side of the board. Low side. Sorry, high side. Low side. Low side, high side, and they all look damn near identical, don't they? This is the drive wave. The drive wave is good for checking because it can tell us a lot about the health of the amplifier. So let's put this onto DC coupling, and so that DC coupling on the scope negates any DC. So obviously you've got DC coupling which shows you the DC that it's riding along. If we AC couple it, it negates the DC, so we can now zoom in on our drive wave, which looks like this. It looks alright. Looks pretty good. Ooh, that's a bit more wobbly on the low side. High side drive and low side drive will always look a bit different. As long as it's nice and sharp and it's driving them correctly, then it's fine. Fortunately, we've got a good side over here we can compare to. So let's check the. Yeah, that looks about the same. That's the same. Yeah, to be fair, this is what I'd expect from these amplifiers. It's not looking too bad at all. Not looking too bad at all. So that's been on for probably about a minute now. And let's check for heat on these FETs. Okay, so the FETs, they're all getting warm in a uniform manner. So all the FETs are warming up to the same amount, which is not a bad thing. Because we've only got one FET per bank and there's quite a high voltage here, they will get slightly warm if we've only got one FET per bank. If we were to fit all of the FETs in here, then they would stay stone cold. So if they're getting a little bit warm but they're all getting warm to the same amount, then there's no issue. It's only when you have one bank that gets stupidly hot pretty quick that there's an issue. Sadly, only 40 people watching. That's fine. That's fine. What I'm going to do is I'm going to chop this video up and then I'm going to make a different video. Let's see what we've got going on in the chat now as well. Matt said just a hobby for benefit. Wicked, man. It's a wicked hobby to have. Fucking brilliant. HD Vids RO says I also repair amplifiers here in Romania, so I came here to steal some knowledge. Also watch all of your videos. Cheers, buddy. I'm glad that the knowledge is rubbing off on you. I'm learning the trade for myself and for side money. Wicked stuff. Says Chevy's not Hondas. Basehead 30, I'm making my old lady watch it. Best channel to watch for learning this. You've helped me tremendously, says Josh Hansen. Wicked, man. I'm really glad. That's all I want. I want to share this knowledge because there's not enough of it about, to be honest, about the amplifier repairs. I like the fact that Sam can read a question aloud and answer them like this. Very helpful. Yeah, man, that's the plan. That's what I wanted to do with these live streams. It does mean that the repair videos go from being 1 hour to 3.5 hours, but yeah, if that's the case, then that's fine. Give it time. I think it's great for a start. Watched it all day. Thumbs up, says Basehead 30. Wicked, man. I'm glad you enjoyed. So yeah, this amplifier seems to be repaired fully. I'm just gonna give it one more run. I'm gonna leave it on for a little bit. And what we're going to do is we're going to measure the, we're going to look at the temperature on the IR camera. We're going to look at the temperature on the IR camera. Just make sure they're all heating up equally, which they should be. We can also check the heat of the driver circuit. Wow! Okay. Oh no, that's fine. The driver circuit is heating up in a uniform manner as well, which it should do. Yeah, it looks pretty good. I was saying wow just then because I had a hotspot, but I just remembered that there's actually a real pull-down resistor. There's a big resistor on the board here that's actually dissipating quite a lot of current, quite a lot of voltage, so that will heat up. Okay, let's check this resistor, this MOSFET here. What temperature do we have on here? So we have 30. What's that? 35 degrees on this FET, 36 degrees on that FET, 33 degrees on that FET, 38 degrees on that FET. What have we got over here? .37 degrees on 38 degrees on that FET. So they're all staying around about 35 to 38 degrees. 32 degrees, 33 degrees on that FET. This, I'll tell you what, this temperature sensor is bullshit. The heat sensor is so far off target from the camera, makes it bloody makes it a bit annoying to measure. 33 degrees. And this one we have 36 degrees. So yeah, they're all within about 4 degrees of each other. So that says to me that the operation is as it should be. Yeah. So they're all getting kind of warm, but they're all getting warm to the same amount. That's because we've only got one FET per bank, which is what I'd expect. Cool. So, wicked stuff. Seems like we have a successful repair then on this one. What I will do though is I'm going to make some adjustments, some small adjustments to this board, so that it is more reliable going forward in the future. So some changes that we're going to make to this board once we have finished the main repair. I'm going to use different FETs on the outputs. This uses 9640 and 640N output FETs, which are okay, but we can use some better FETs, and the better FETs which we can use are FQP, they're 12P20s and 90N20Ds. Can't remember if it's FPQ or FDA. What is the starting prefix of those? Well, we can probably check it actually. I've got a whole bunch of them here. FQP 12P20 and FQP 90N20D. Oh man, this is it's almost 3 in the morning and I have no idea what I'm talking about. Anyway, better FETs on the output section. We're gonna strengthen up this previous repair on the driver board because I don't trust it. It doesn't look that great. So we're going to run the heat gun over that. Another thing we're going to do to help this amplifier do a little bit more power is I'm going to thicken up all the traces. So if we have a look on the bottom of the board here, if we want this amplifier to do well at 0.5 ohms, then we need nice current handling. So what we can do is we can thicken up all of the traces where the power is being power paths. So from the power supply section, that'll be these great big metal, these great big pads here. We can also sort out these traces from the transformers. Looks like this has been desoldered at one point. Doesn't look that great, so we sort that out, thicken that up, and the power path for the output actually does look quite thick already on this board, but I'm going to add some thickening cables anyway, which should help it do a bit more power at those low impedances. The transformers and the inductors, they look pretty well seated, and they're actually completely covered in CA glue, which is a very nice build quality, so we don't need to add any more CA glue to any of those to prevent from vibration. We are going to put some CA glue on the driver board so it doesn't wiggle its way out under vibration. What else can we do? Apart from that, I think we're going to be good. So yeah, wicked stuff. Wouldn't everything at least be room temperature? Well, no, if things are heating up, then they'll obviously be higher than room temperature. So these MOSFETs, they're driving the inductors. You see these inductors? These inductors, they filter out the high frequency switch wave that you see on the scope. Got about, what, 125 kilohertz or something going on there? So these inductors filter it out so that you're only left with a clean audio signal. By filtering that out, they actually do put a load on the MOSFETs, because obviously the MOSFETs they're driving them to some extent. It's being filtered, so they will get slightly lukewarm, even under no load, which is fine. That's fine. What else we got going on in the chat? Yeah, what we're gonna do is we're gonna put this. This is fully repaired now. So what we're gonna do is we're gonna fix this up tomorrow. We're gonna put the all the FETs back in, the new 90 and 20. We're gonna put the 12P20 FETs in tomorrow, and then do a bench test. YouTube never gave me a notification, damn it. Yeah, you need to click the bell on my subscription thing. But weird if it's still... Check your spam email. I know YouTube is a bit shit sometimes at letting you know. My voice hurts. Getting some killer high frequency interference here. Ah. Still got it? Let me know if you still got interference. Oh, it's my whistling. Probably was. Like an amp dyno, can only tell you so much, seeing how the company laid everything all out for the path of least resistance and the parts they used. Yeah. I thickened up the traces on my amp I'm repairing. I thought that was a great thing to do. Yeah, it is. It is a great thing to do. Yeah, any thicker path for the power to go down is great. Glue that wire repair. Yeah, that's a good plan. We'll do that. We'll glue that wire repair as well. What's the difference in thin wire and thick wire output inductors? What do you mean? So we've got the board here. So these are the transformers for the power supply. So they take 12 volts AC and bump it up to, I don't know, whatever the output rail voltage is. These are the inductors, and they filter out the high frequency switching wave and prevent it from getting to the subwoofer outputs. Chevy not Hondas, I should check your song out for sure. Actually, should we check it out now? Should we check it out now? It'll sound horrifically distorted through your speakers. I do apologise because this microphone is very sensitive. Where did you send it to me? And I'll check it out. We're going to check out a song that Chevy not Hondas sent me. You sent it to my email? You guys are going to see all my emails now. Ah, that's not what I want to do. Yeah, did the stream just cut out? I think OBS crashed. Do I like bassline music? 4x4 stuff. Yeah, I do, man. Yeah, I fucking love bassline. I love bassline. I started all off on bassline. Chevy Not Hondas, where did you send me the song? Where did you send the song? Did you send it on my Facebook? Did you send it on my NSV page, maybe? We're just going to quickly check out this song and then I'm going to hit the sack because it's 3 AM. NSV repair page email provided. Oh, that might be the SPL Lab email address then. Here we go. Fine remix. Where is it? I don't seem to have any attachment here. I've no idea what this sounds like for you guys. I've no idea what this sounds like for you guys, by the way, if it's too bassy, too loud, or distorting on. Holy shit, that's actually pretty good. So Matt, that's you. That's fucking wicked. That's fantastic. If you made that, that's awesome. That's really cool. Nice one, brother. That's wicked. I shall be adding that to my likes. Adding that to my likes for sure. No, that's fucking wicked. Yeah, no, I'm a proper old bassline head. Proper old bassline head. If you're into bassline, DJ E1D on SoundCloud is awesome. Very good. Loads of fantastic mixes and tracks here. Modern bassline and UKG and 4x4. music. Okay, yeah, we're going to lock this off, so thank you very much to everyone who's stuck with me till the very end of this repair stream. We got the solid audio up and running, which is good news after some fucking headaches on the power supply section. So cheers very much for tuning in, and tomorrow I shall be fitting the 12P20s and the 19N20Ds on the output section and sorting out any reliability issues that we come across with this board, putting it back together and doing a bench test. I'm going to do a 1 ohm bench test, 2 ohm bench test, and a 0.5 ohm bench test. So yeah, have a good evening guys. I'm going to go and get some rest, and stay tuned tomorrow for the next repair video. If you missed the stream, no worries. I'm going to cut this stream up into parts. So on YouTube, it won't be one long 4-hour video. It will be cut up in parts so that you can watch little bits at a time, and it's all labelled up. What time tomorrow? I don't know. It's probably going to be around about 8 o'clock UK time, 8 PM UK time. So yeah, wicked stuff. Thank you very much, guys. I shall see you tomorrow.